So now there are best practice by which you can prevent the lack of fission. For an example, for TIG, it means welding. Not to use too large the root face. Root face should be correct, so that, and welding current should be sufficient, so that welding pool, it can penetrate fully the root. MMA, that is TIG, means tungsten inert gas welding. MMA, that is metal uh, arc welding, that is uh, the correct current level, not too large electrode size for the root. Otherwise, it will not reach to the fully, it will not penetrate full. MIG welding, sufficient high welding current level and arc voltage should be kept. A short arc length should be as short as possible. So this configuration of the joining gap is important. Adequate size has to be there, that is the root space. And do not use too high current level, causing welding pool to bridge the gap without fully penetrate. And there should be some care and storage of electrode should be, because electrode, if it is dry, then what will happen, it will have the moisture, and the moisture will cause the more spattered, as well as because the coating material, it can absorb water, and that is the moisture, and coating coating will get deteriorated, and subsequently what will happen, the hydrogen will pick up. So the hydrogen is one of the problem for our welding. So special care should be taken. That's why you use the electric heater, so that you, in a container you put, that is having the electric heater, so that temperature is maintained, so that moisture does not it is, and don't keep the consumable in damp atmosphere. So increased spatter, that is the striking difficulty will be having for weld bit, and there will be porosity and harsh arcing characteristics will make, because these are the indication of the poor electrode condition. And electrode profoundly influence the welding and welding metal quality. Simple fabrication of plain carbon steel, demanding the joint is high strength material, because it has to be very high strength, and a manual metal arc continues to be processed, used, which is widely we do use the MMA, that is the manual metal arc welding. And electrode coating, it's deteriorated, then that is the indication we can get that the welding metal porosity, arc instability, excessive spatter, poor bed profile, undercut, poor slug release, heat affected zone cracking, all these defects are one of the major problem with the uh, electrode condition. But there are other also, the current and voltage should be incorrect, and preheating has to be done. That's why the care for electrode is relies consistency of the performance of the electrode, and flux coating should be chipped and cracked. Suppose the should not be chipped and cracked. Flux coating should be, because it has got some purpose. So more important, it's allow become a dump. If the this flask actually provide a shield around the welding, so that if it become, so that heat energy cannot move away from that, because you need high heat energy for metal to get melted. And also, if you don't have that shield, then what will happen, from outside the foreign particle can go to the welding metal, that become the inclusion. So well ventilated place you keep, and good practice to stack packet in wooden pallets or the rack, clear of floor, because floor is dump atmosphere, and unused electrode which should be returned, not to expose in damp condition. And good storage is 10 degree centigrade above the external air temperature, that is the good storage, so the moisture will not absorb by the coating. And storage condition should be such, so that prevent moisture condensing on the electrode, the electrode stored and dry rather than warm. So Now the condition of the original packaging of the electrode stored, it is like the electrode are not now available in hermetically sealed packets so that no moisture can enter into the packet. So then it needs, it means the it remain dry. An unused electrode, it has to be dried according to manufacturer instruction, and drying of the electrodes. Drying is usually carried out following manufacturer recommendation. They will say that how to that usually all the makers decide that you have the container with the heater and then you keep it dry condition. So the lack of penetration for British standard 5817 3 quality level, it has got level B, C and A. So B is the stringent and the C is the intermediate and quality A is moderate. Short of lack of penetration is permitted for A. B and C is not permitted. And incomplete root penetration is not permitted for the pressure vessel. Pressure vessel, it is not permitted because then it material will fail. So then the remedial action, root cannot be directly inspected. So what is been done? NDT is been done. One of the NDT is penetrant or the magnetic particle. Penetrant gives you the surface defects, crack, but magnetic particle, it gives the internal crack also, surface as well as internal. And detection is by the radiography or the ultrasonic inspection is been done. It's like X-ray. And remedial action, removal, suppose there is a crack or defects, then you'll have to gauge it and grind it to the sound metal and then re-weld it to the conformity level. So welding, fusion welding joint in steel, nickel, titanium and other alloys, beam, it is quality level for imperfection. It means the as per the standard, what is the imperfection, that has to be then repaired. For pressure vessel, it is very stringent. So how the test is been done at the end of the pressure vessel A and B, you have the test piece and then you cut it off from the, and this welding has to be tested. It goes for testing. So this is the test has been carried out. One is the all welding metal tensile state test is carried out. B is the bend test is carried out. 3 is the tensile test for the joint, and then 4 is the macro test specification, and then impact test. Macro and micro is for the like the how the how it is internal molecules, how it is structured. So that is checked by the microscope. That is macro and micro is being checked. Now the gas welding, how the gas welding process is, which melt the joint metal by heating and then with the flame, and then reaction of the fuel and the oxygen, because flame is the as containing the oxygen and the fuel, and then the combustion takes place and the heat is released, and the that temperature is very high, that is the flame temperature, and the flux maybe deoxidize and cleanse the metal, weld metal, and flask melt to solidify and forms a slack skin on the resultant weld metal. So this flask is it 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 is a slag. Actually, slag means impurity. That moves upward direction and then it floats. It's been lighter than the weld metal. It floats on top and it makes a skin, and then you remove that. So, but you need to have the flask to have the protection. Actually, the heat energy does not allow to come out, as well as the foreign particle should not go inside the welding pool. So utilization of the oxygen and the fuel to heat the metal, because it increases the temperature and then it melted, molten state it become, and it become a fused metal together. Both the metal then get fused, and the filler rod can be used, because once it gets fused, then because there is a gap, And what will happen to the total volume of the metal is same. So there will be filler metal. That filler metal has to be dot is to be used for the filling that gap, that volume. So this is the uh, fuel and oxygen. It comes from the uh, torch, and then you have the filler rod which gets melted, and the base metal also gets melted, and then it gets solidified, it gets fused, and the two metal it gets joined. So this is the like you can see, this is the protection envelope. So this is the protection envelope. This is so that the heat energy does not come out, as well as the foreign particle, it does not enter into the uh, space where you are doing the welding pool. There is no inclusion, and the slug will get will solidified at the top, and then you remove that slag. So this is the gas welding. Butt weld is the strong welding. So this is the welding phase. So this is the workpiece, and this is the heat affected zone, because when you are doing the welding, surrounding will be heated up. So that is the heat affected zone. And this is the welding metal, and this is the welding bit. So welding phase, the parent metal, this is the welding zone, because including welding zone is including the heat affected zone. And this is the fusion line where it joins with the metal, the parent metal. And this is the toe, and this is the excess weld metal, because it has completely root penetration is done, then it will come out. And on top also, this is the excess metal. So this is the these two are the excess metal. Most of the cases we go for the butt welding because it is stronger. So butt welding, it is the simple and simplest and the verticile type. And the joint is formed by placing two pieces of metal end to end, and welding is along the joint. And the butt joint, the surfaces of the workpiece has to be prepared. It is on the like V shape, and then metal within the plane of the surface. It means the workpiece being joined together, it is on the same plane on the surface. If you see this, so this is the workpiece, and this welding is on the same plane. And the workpiece are nearly parallel and do not overlap. The workpiece will be on the same plane, and they don't have overlapping. Like lab, the fillet welding, you have the overlapping. And the, depending on the thickness, metal pieces, a different type of groove is prepared. It can be, if it is full penetration, then it will be V, and at the bottom there will be like, it will be like this. So this is the root, and then you have the V. So this, depending on if it is, you can be having like this also. You weld from both sides. If you welding from one side, then it is the full penetration. So accordingly, you make the preparation. It can be V, it can be J, it can be U, and group design is changing depending on the full penetration, partial penetration, like that. And groove welding, it's carried out, and then the different type of welding you can have. You can have the manual welding, you can have the mechanized and automated welding. Uh, like there are automatic welding also you can have. It moves with the electrical motor, and it does the welding. And thin sheets, usually it is welded. Edge preparation is not required for the thin piece, thin sheet. And bar joint welding, using the arc welding, if you do resistance welding also, you can have high energy beam welding, like heat energy has to be supplied to melt it. So different form of heat energy you can uh, supply. And weld pieces held together and tack welded first, and then you will go for the continuous welding. And butt welding is commonly employ various shipbuilding, piping, automated energy and power. All the ships, most of the welding we go for the butt welding. And type of butt weld joints. These joints, particular shape you'll have to have, because that edge preparation what we have seen. And all cases the welds are end to end. It is pieces end to end we weld. And thickness of the parent metal, it should be slightly more than the thickness of the parent metal. And control of the distortion of the welding assembly. It is important that the control weld penetration and double penetration joint design. And the welding should, there should not be defects, so that quality can be controlled. So this is the butt welding. And the gap, that root gap, it can be 2 to 3 millimeter. It depends upon the welding rod. As I told you that if you put the welding rod, if you see the, it means it should be minimum, that gap means it should be slightly, it means your root gap should be such so that you can put the electrode inside, so that it can have the full penetration, so that the filler metal fully it can penetrate. 2 to 3 around we keep the gap. And advantage of butt welding, the high strength and complete fusion you can have, and easy to machine. And distortion you can control, because you can maintain the correct parameters, and the distortion can be controlled, and easy to inspect. This butt welding, because it is a parallel phase, means it is on the same plane, so it is easy to inspect. Disadvantage: welding geometry can limit the application, because it has got limitation. There is no overlapping. Suppose there is two plates are overlapped, how will you do the butt welding? You cannot do the butt welding. Then fixturing and the backing is required. Why it is backing is required? It means at the, if suppose it is full penetration, at the gap, root gap, the backing is required. It means if you see this, at this position you need to have the backing. So there is a backing plate. You can have a plate, you can have a strip. Nowadays we use the strip at the back, so that the backing is required for your uh, butt welding. And sensitive of firing the surface condition. It means surface condition, that is the surface finish has to be good, so that you can have the better welding. Whereas for the lap joint, you don't need the surface finish. Butt versus sorry, the fillet welding, that is the, for the lap joint we use the fillet welding. So what is the main difference between this? The weld is the angle between the joint workpieces, and the surface to be joined are to be same plane, that is for the butt. And butt weld and surface to be perpendicular, that is 90 degree for the lap, that is the fillet joint, fillet weld. And weld preparation is not required for the fillet weld, but butt joint it is required. And a fillet weld joint, filler metal is deposited, On a triangular section, it creates an angle of 45 degree. We'll see that in the diagram for joining the workpiece. And weld joint is thickness, and the welding is carried out in several passes. And distortion occurred in both fillet and butt weld as a result of shrinkage, because when the temperature in that you are doing the welding at higher temperature, when it's cooled down, what will happen? There will be a shrinkage. Then there can be a distortion. That's why when on ship you'll see when you are doing the welding, sometimes the plate has become buckled. Because why it become buckled? Because of the shrinkage. That's why it is the certified welder, they know what they do. They preheat the area and they do the welding. Once they preheat, then the already plate is expanded. After that, if that shrinkage, it will come back to the original size. So this mitigate preheating is required, and making successive passes and opposite side, and the temperature also is maintained. The fillet weld, the T, lap, corner joint, those are the fillet welding we have. And this and we use the arc welding process we do use. So these are the fillet joint we have. It means if you do the, what will happen? It will have a 45-degree angle will be having. Here one fillet joint, here fillet weld. This is fillet weld. This is fillet weld. It will make a triangle like this. So these are the penetration, and then you have deep penetration fillet. Then the S, you can see S, and meter fillet. It means the filling is done only up to the surface of the metal. Now the welding machine we do have. In welding machine, alternate current and direct current both we use. AC and DC, both forms are arc welding, and different currents are produced in the electric arc. So welding involves is creation of electric arc, so that it gives us the heat energy to melt the metal, and metal being welded, then it gets solidified. So power supply generates the arc, and alternate, it can be alternate current and it can be a direct current. DC and AC both we are using. And it decides, like the source of power, AC or DC, it will decide on the polarity of the electrical current which runs through the electrode. And also it is the impact of the weld produce, how there is an impact on AC and DC. And correct electrode polarity impacts the strength and quality of the weld metal. And there can be straight or reverse. It means two type current flow called electrode negative and electrode positive. For a DC, polarity is constant, there is no change, whereas AC polarity changes. It means the AC, for AC, the electrode has to have a both the polarity, reverse and the direct, because it's one half it is changing in one direction, another half is in other direction. So DC can have the single polarity. So for one direction for half of the time, and half of the time for other or the reverse direction for the AC. So direct current is an electric current that constantly polarity does not change, and single direction. So it can be positive or negative. It means the DC welding magnetic field and the current are a constant. Suppose positive is connected to the one end and the negative connected to the other end, then it means the other end become negative, then it is like one direction. And then if negative is oppositely it is connected, then it is called a negative. So DC, it can be positive or negative, but for AC it has to be reverse. So there are advantage of DC and disadvantage of also DC. So DC welding, the smoother welding output, than the AC, and more stable arc we have because there is no change. It's the direction is one direction. Less spatter you get, and DC negative offers a faster deposition rate. And welding also it can be thin sheet and very high thickness also it can. And a DC positive provides greater penetration in the weld metal. It means when the thicker metal you are doing the welding, you will go for a DC positive. When it is negative, then thinner metal negative, DC negative means the current is flowing in one direction, but which direction it is flowing, the positive or the negative, that means you can change the polarity, and depending on based on that your electrode also will be like that, and the negative or the positive. Disadvantage of the DC, the it unable to fix the arc blow problem. That is the main problem. That's why we prefer the AC current. We don't use the DC current usually because there is a unable to fix the arc blow. Arc blow is a problem. We'll see what is that, and more expensive as DC current requires internal transformer to switch the current from AC to, then converter also you need from AC to DC. And when that is the and when we are welding the ferromagnetic steel, lack of fission and imperfection can be caused through the uncontrolled uh, means deflection of the arc you can have. That is the arc blow you can have for the DC. That is the disadvantage of DC. And magnetic arc blow is known as the arc, that is a deflection of the arc. When you are doing the welding, then what will happen? The arc will have a deflection and causes the distortion of the magnetic field and produce the by the electric arc current. So what will happen? It will not remain in a straight line. The welding metal, that is the arc deflection, it can cause the distortion of the magnetic field produced by the arc current. And if you see, this is the arc blow, so it will not remain in the straight line. Then what will happen? That will be a defect, welding defect. So we don't, it means the person who is doing the welding, he has to control that arc blow. He has to know he has to be very highly experienced person, because there is an arc blow, it will deflect from straight line, it will deflect in one side, and how much it will deflect, that also you need to know, so that you can change the angle of the electrode. So it is very difficult. That is the reason we use the AC current. And application: thinner joint metal, and then TIG welding for steel. These are the overhead welding, we use the DC, and vertical application also we use the DC. AC welding, alternating current we apply, and usually it is 60 hertz for an example, the current. So it changes the direction. Uh, so it changes the direction, suppose 60 hertz. So 120 times the polarity will change, because in 1 hertz it will change twice. Half is the one direction, another half is another direction. So per second 120 times it will change, and there are advantage of it. So arc welding, a magnetic field and the current rapidly reverses in direction, so there is no deflection of the arc. An advantage: alternating current, the positive polarity and the negative polarity allow a steady arc and welding magnetic parts, and fixed problem with the arc glow. There is no arc glow, and enable effective aluminum welding also. And AC welding machines are cheaper than the DC equipment, but there are some disadvantage. More spatter, it means you'll have to control that so that the welding pool does not get disturbed. welding coating should be dry, and weld quantity is not smooth as the DC welding machine, and less reliable and more difficult to handle than the DC welding. But still we use the AC because of that arc glow. So this is the welding part. Any question on this part? So then let us start the next topic. So next topic is air compressor. So the usually we do use the two-stage compressor, and main air setting compressor uh, is we use the reciprocating type compressor, because the reciprocating compressor, it can increase the pressure. What we required for the starting of the engine is around 30 bar. We use the high pressure it can create, whereas for rotary compressor it will not be. And single stage we don't use, because if you use the single stage, what will happen, at that pressure the temperature will be very high, and the component has a limit for the temperature, as well as your oil also has limit for the temperature. Oil will get carbonized. So that's the reason we use the uh, double stage, means the multi-stage compressor. It is two stage. We usually on three stage also we use two or three stage we do use, and the lube oil temperature also is reduced, as well as we can use the and the component temperature is also is reduced, and we can use the intercooler. If we use the intercooler, we can save some energy, that is the work done is reduced, so that the efficiency is increased. So in this diagram, if you see how it is, you have got LP and HP. There has to be LP and HP diameter of the piston will be less than the LP. Otherwise, volume will not reduce. Then how will you compress further? So if you see this schematic diagram, so this is the crankshaft, and it is supported by the bearing. So these are the bearing. And at the end, you have the lube oil pump, which is generating the lube oil pressure, and then the bearings are cooled, and this is the crank pin bearing. Crank pin bearing also is cooled by the lube oil. And you have the LP first. What will happen? There is an intake filter, because no dust should enter into the compressor. So that then what will happen? There will be the abrasive wear, and it will affect your cylinder lubrication also, and abrasive wear that will damage your wear down will be higher. So the clean air should enter when the LP piston is moving downward direction. The top of the LP piston, the volume is increasing, and then the suction valve will open, because moving upward direction. Then what will happen? The delivery valve will open. That time the suction is closed. When the suction takes place, that time the delivery valve is closed. So through the delivery valve, it will go to the intercooler, where we reduce the temperature. Once we reduce the temperature, then what will happen? We reduce the temperature so that, suppose the inlet temperature is T1, and delivery temperature will be higher than T1, because it gets compressed and the temperature increases. And after suppose this is T2 at this point, and after that you have the intercooler. After the intercooler, we bring back to T1, and after that HP stage, it is the same thing like when now one thing you see that the arrangement is such so that when the delivery takes place in the LP side, the HP that time the suction takes place because this mass of air has to enter into the HP side. So the suction takes place. When it is at TDC, this is at VDC. After that, what will happen? It is get the pressurized again once it is suction, because when it is moving in a downward direction, the pressure drops, and from the intercooler, after cooling, it enters into the HP cylinder at T1 degree centigrade. And after that, it gets it will move in upward direction. When it is moving in upward direction, then that moment the LP piston is moving downward direction. So suction takes place in LP and the delivery takes place in HP. And then what will happen? Here the temperature will increase, T3 will increase, and then what will happen? It has to be cooled in the after cooler, and then it goes to the air bottle or the air receiver, because at this temperature we cannot send it to the air bottle, there can be an explosion. So this and both stage has to have safety valve. So there are a safety valve in intercooler and the aftercooler. So this is for the LP, this is for the HP. So this is the basic diagram of a compressor. And another thing, if you see, the PV diagram, this is P, this is V. So and suppose if you see this, so if you make a single stage, then what will happen? As the pressure increases, temperature also increases. So what will happen? The temperature will be very high temperature. So what we do, we make the two stage for an example. We have the three stage also. Air cooled compressor, it is more than the two stage. Water cooled compressor, we use the two stage, and 3 to 4 stage we use for the air cooled, because air is not that effective. So what do we do? In the here you have the intercooler. In intercooler, we cool it down. Once we cool it down, then what will happen? It means our line will follow this line. It will not follow this line, what I had drawn. So it will follow this line. It means we, sorry. So what will happen? This, it is coming here. After that, we cool it down. So it will become like this. So after that, in second stage, the inlet is same as this is suppose T1, and this is also is become T1. This is T2. So because of cooling, it has reduced the temperature, and then it has reached to T3. So what had happened? PV diagram. What is PV diagram? That is the work done. So this much work we can save, as well as the temperature of the component and the lube oil temperature also will reduce, so the it will not fail, and the lube oil also will component will not fail, as well as the lube oil also will work in good condition, because otherwise what will happen? It will become a carbon deposit will be having, because the temperature is high, and you can have the explosion also if that temperature. Lube oil, what is lube oil? Is a fuel, so you can have an air is plenty there. So what we actually try to do, the temperature for first stage inlet and the second stage inlet, we keep same, so it become isothermal compression. So, but in practice, we cannot have the complete isothermal. So we have the polytropic. Uh, Means adiabatic is the maximum power consumption, isothermal is minimum. So in between we get, that is called polytropic compression. And if you see the pressure, the LP is 5 to 6 bar. It means from 1 it has reached to 5 to 6 bar, and HP is 30 34 bar. From 5 to 6 it is compressed to 30 to 34 bar, and if you see the ratio, it remains same. So 5 1 is to 5 or 1 is to 6, and 5 is to 30, so it is 1 is to 6 around. So it will be we keep the compression ratio same, so it gives us the balancing of the compressor. And the first is stage discharge before the intercooler, it is around 140 degrees centigrade. And first stage after cooler means the after the intercooler, the temperature become 35 degree centigrade. And second stage discharge after before the after cooler, it is around 140 degree centigrade. And second stage after cooler, it becomes 35 degree centigrade. And inlet to the compressor from the engine room is around 35 degree centigrade. So it is like we are getting the same temperature due to the intercooler and the aftercooler. And then at 35 degree centigrade, it goes to the reservoir. So this is another diagram which shows the lube pump and the sump also. So in this case, you have the HP piston and piston guide. HP piston has got the piston guide, and then you have the intercooler and the aftercooler, and exactly the same way LP piston, it's drawing the air from the atmosphere through the filter. And then remember one thing, that never use the compressor removing the air filter. Air filter has to be there, otherwise you can have the explosion and your compressor will get damaged very fast. And then you have the drain valve. Here it is shown the drain valve. You will be having the drain valve in the uh, intercooler and the aftercooler drain, because in the cooler, aftercooler and intercooler, what will happen, once you condense reduce the temperature, the moisture will get condensed, and then moisture will get separated from the air, and the oil also will get condensed and get separated. That should come out from the system. It should not go to your air reservoir, because that oil is a source of so it is a fuel, so it has to remove from the system. And lube oil pump is driven by the crankshaft. Now the cylinder lubrication, we have the lubricator through which the system oil, that is a lubricator, and we can adjust the flow of that lubricator. So how much it will be, it enters into the cylinder, the top part, which cannot be uh, lubricated. So it enters with the air which is entering into the cylinder from the suction, means the LP side, and then that air remain into the your means that oil will remain into the air, and then that gives the lubrication of the cylinder. Liner lubrication is done like that. And the suction and the discharge valve, they are non-return valve and low inertia valve it has got, so that the inertia effect is, it means it has to open and close instantly. Now the typical auto starting of the compressor, what you have, start off for the lead compressor. You can have lead compressor, you can change the lead also. Number one, you can make lead. Number two, you have the selector switch. Number two, then standby, and the number two, if it is lead, the number one will be standby. So the first lead compressor will start first. Suppose it reaches to 35, 30, 25, 23 bar, the lead will start, and lead will stop at 29 bar. And sequential startup of the standby compressor is 21 bar and stop at 29 bar. So what will happen? Suppose the lead has started during the maneuvering. Lead has started. The air consumption is such, so lead will not be able to increase the pressure. It has 23 bar. It has started, but the pressure is still going down because of the consumption. So what will happen at 21 bar when it reaches, the another standby compressor will start, and then both the compressor will be running, and then it will stop at 29 bar. Sometime the standby will stop at suppose 28 bar, and then at 29 bar the lead will start. It means the number means the standby compressor is giving support to the lead compressor, because lead cannot alone do the job because the pressure is reducing. So the standby one will start. There is another type of compressor we can have, that is the tandem compressor. A tandem compressor has got one single piston, but it is a two-stage compressor. So what happened here, if you see, the diameter of the piston is different. At the lower part is a smaller diameter and the upper part is larger diameter. Then what will happen, you have the filters. When the piston is moving downward direction, what will happen to this volume? The volume will increase. What will happen to this volume? It will reduce. So once the volume is reduced, increasing on top, the suction valve will open. Air from the through the filter, it will enter into the compressor. And then when it is moving upward direction, then what will happen? The volume is reducing. That time the suction is shut and the delivery valve will open, and then it will go to the intercooler. Intercooler is the function is same. It gets cooled down so that it temperature is reduced, as well as the moisture and the oil gets condensed, and then there is a drain. Through that drain, it come out from the system, and then it goes to the second stage. This is the HP stage. So when it is moving, when it was moving downward direction, the delivery took place from here, and now it is moving upward direction. Then what will happen? This delivery from the top will come to the suction of the HP cylinder, and then when it is suction takes place on top, then the this is moving down, the delivery takes place here. After the delivery, after cooler, same purpose, and then you have the relief valve in the, or the safety valve on each stage, first stage and the second stage. So this is another type of lubrication. I mean, another type of compressor you have. And lubrication, as I told you, the top part splash lubrication you cannot have. So what will happen? The top part will be lubricated by the there is a lubricator, and the lube oil pump part of the oil is going through the lubricator with the suction. It enters into the cylinder. It gives the lubrication of the valve cylinder and the cylinder liner, as well as the piston ring, as well as it gives the lubrication for the valve also. And here you can lower part of the you can have the splash lubrication. Once it splashes, then the lower part gets lubricated. But the top part, it has to be, that's why you have the scraper ring. And top part, it is lubricated with the air. Now, if you see the PV diagram, this is BDC and this is TDC. This is BDC and this is TDC. And what will happen from one, it pressure is increasing, that is the compression when it takes place, then what will happen, that up to this, once the piston is moving from BDC to up to this, and the compression, the pressure will be sufficient to open the valve. So valve will open because the maximum pressure difference will be there because the cylinder pressure is a maximum, and it will open suddenly. Then what will happen? Once it opens, then slightly pressure will drop inside the cylinder. After that, it will again slightly increase. This is called valve bouncing, and then it will slowly it will reduce to P2. At P2 it had opened. Then what had happened? The moment it is sorry, this will be opening at 3, because the at 3 it will be opening because it has to overcome the inertia force. So it will open at slightly higher pressure. After that, it will reduce, and then it will have the bouncing effect because of the valve will slightly close, slightly open, like that. And then at 4, what will happen? The valve will completely close at that pressure. And after that, what will happen? It has reached to TDC already, the piston from BDC. After that, it will start moving in this direction. Once it start moving in this direction, then what will happen? The vacuum will create. But the suction valve will not open immediately. Suction valve will open at this point. So the pressure difference has to be created, then only the suction valve will open. It means inside pressure has to drop below the your atmospheric pressure, and it has to overcome the inertia effect. That's why low inertia valve is been used, and the spring also low inertia spring. So after that it will open. Then what will happen? Once it opens, the inside the atmospheric air will enter. Then what will happen? Slightly the pressure will increase, and then there will be a bouncing, and then slowly, because your piston is moving downward direction, the pressure is falling inside the cylinder, and uh, that atmospheric pressure is entering into the cylinder, and then slowly it will increase, and it will come to the atmospheric pressure. It will maintain at atmospheric pressure. So after that, because once then the suction valve will close, and then again the uh, compression will take place. This is compression, and uh, this is the suction. It means suction valve will open at 5. It has to come below the atmospheric pressure. This is the suppose atmospheric pressure. And now what is this your cylinder head? There is a gap between the cylinder head and the piston top at TDC. That is called clearance volume. This is clearance volume. Because we need to keep some clearance volume, otherwise what will happen? At the working temperature, piston will expand, piston will hit the cylinder, so it will get damaged. Both means the component will be, piston will get damaged, cylinder also will get damaged, other part also will get damaged. So we'll have to keep a clearance. But what happens when the compression takes place? Then the pressure is high at P2 when the valve is closed, delivery valve. So inside pressure is P2. Now this P2 will expand. Once as the piston moves this direction, P2 will reduce. At one point it will be below the atmospheric pressure, and till then though it will no suction will take place. So what will happen? If your clearance volume is less, then the more air can go out from the cylinder. The less mass of air will be there in the cylinder. So this is a loss actually, the clearance volume keeping, because the high pressure air again it is which has been compressed has been expanded. So then what will happen? The expansion will be less distance. Part of the stroke is used for the expansion. So this distance will be less if your clearance volume is less. So this is, suppose this is the distance which has to move, then the suction valve will open, so it will move less. because if the clearance volume is less. That's why the clearance volume should be as minimum as possible. What does it mean? This much volume you gain. Volumetric efficiency increases. If the clearance volume is high, the volumetric efficiency will reduce. So there are we need to keep some clearance volume, but it should be as a minimum as possible. So the safeties for the compressor, you have the relief valve in each stage. You have the bursting disc. Where you put the bursting disc? Bursting disc is put on the water side of the jacket if there is any leakage of the air. Air is in higher pressure. Then what will happen? The air will damage your cylinder block, cylinder line, cylinder. So to protect that block, you have the bursting disc. So that bursting disc, once the air, high pressure air entering into the jacket, then what will happen? The bursting disc will burst, and then uh, the pressure will get released. So your the compressor will shut down because of the low water pressure. Water pressure is around 2 to 3 bar, and your air pressure is much higher. So that will burst the bursting disc once it enters into the uh, uh, into your cooling jacket water space. Then you have the fusible plug. Where you have the fusible plug, that is on the discharge side. Based on the temperature, once we have seen that the temperature should be after cooler it around 35 degrees centigrade, because high temperature we cannot send it to the reservoir. Then there can be an explosion, fire hazard. So the pressure, the once the temperature increases, so this fusible plug will melt, and then once it gets melted, the air, the delivery air will get discharged. It will not go to the through the fusible plug. It will not go to the reservoir. So the fusible plug is used on the delivery. That is the after the second stage. You have the uh, we have the fusible plug. So one of you have a question that the bursting disc is when the bursting disc is activated. When there is a leakage, the air, there is a leakage to the jacket side. So leakage to the means air can come to the jacket side. There is a crack. Suppose your cylinder liner is cracked, or your gasket is broken. That cylinder head gasket is broken. Then what will happen? High pressure air will enter into your jacket, and once the high pressure air enters into the jacket, then what will happen? Your jacket can get damaged, because jacket cannot withstand that high pressure. Your cylinder liner can withstand, but the jacket cannot. So on the jacket side, there is a bursting disc. Bursting disc, nothing but a plate, and it is made of copper material or the rubber. Sometime it is rubber material. So this bursting disc will burst, and then because of the high pressure now in the jacket side, uh, because of the high pressure air, and the bursting disc will burst, and the air will get, the pressure will get released, because we cannot pressurize the high pressure we cannot have in the jacket. Then jacket will get damaged. So once the bursting disc is damaged, then the low pressure alarm will be sounded for the jacket water, and then the compressor will trip, and compressor will not be in running condition. And then you see that bursting disc is ruptured. You know there is a leakage. You rectify that. This leakage can also be uh, from the from your intercooler and the aftercooler. Suppose the tube is leaking, then what will happen? The cooler also will get pressurized, and your jacket water, same jacket water is used for the cooling of intercooler and the aftercooler. So the bursting disc also nowadays, because nowadays the construction is such that there is one bursting disc, so that if it is pressurized jacket, so all the areas will be pressurized, and it is connected. All the intercooler, aftercooler, and the jacket, they have the connection, so that the disc is on the jacket, So it will get burst, and then uh, you can save the compressor uh, water side. Is it clear, Abraham? Abraham, is it clear? So then the fusible plug that gets melted, fusible plug is like this. So the fusible plug is like this. And on the pipe, this plug is fitted. You have the thread. So suppose this is the pipe. Suppose this is the pipe. On the pipe, it is threaded. This is the wall thickness of the pipe. So as the temperature increases, what will happen? Then this gets melted, and then it is open to the atmosphere, that is the engine room. So the suppose the supply is coming from here, high temperature. Because of the high temperature, it got melted, and then the air will come out to the engine room. It will not go to the air bottom. And this fusible plug you might not be having if you have the temperature sensor, the delivery of the compressor. If there is a temperature sensor which is monitoring the temperature and giving you an alarm, then the fusible plug is not required. Many of you might have not seen the fusible plug because of that. Now Abraham had asked something, that is the uh, suppose this is the compressor. And you have the cylinder. You have the two cylinder, LP and HP, and you have the uh, jacket's water space. So here on the side you will be having the bursting disc. So this jacket water passage is open to this. So this will get bursted if there is any leakage of the air in the water side, and this water side is open to this, so that it will get bursted, and your uh, the jacket will be protected. Is it clear, Abraham, where the bursting disc is fitted? Nowadays, intercooler
Yes,
and the aftercooler is inside the jacket. So it is only one is fitted. Water high
but Chief,
temperature trip, then
Chief, my
water.
question
Yeah,
is,
tell me.
where, how do we know that the bursting disk is activated?
Yeah. So
When it is
once
activated,
your
what are the indications?
indication is the compressor will trip on low water pressure alarm. Once low water pressure alarm is there, then you see, and you'll be able to see that water has come out from the bursting disc. Once that disc is burst, then what will happen? Water will come out, and you will see water, and low water pressure alarm has come and it had tripped. So you check the bursting disc, you will see it is ruptured. So it's because outside there will be water around that area. At the floor or the tray, it will be inside the tray. Tray will be on the floor. It will be seeing the water. So that the bursting disc, that is the weak portion, it will get bursted. Then any other things get damaged. So the water high temperature trip, water non-flow trip, because what happened, the compressor is arranged such a way, when compressor is stopped, that time there is a valve of the cooling water valve is shut. Why you need that? Because when it is on standstill condition, if the cooling water is still flowing with pressure, then what will happen? If there is any leakage, inside the cylinder water can enter, and once water enters, then when you start it, then what will happen? When the compressor starts, there will be hydraulic pressure inside the cylinder, and the liner and the piston and the cylinder head will get damaged, which you don't want. That's why it is shut. And when you start it, after that the cooling water will start, and then that is non-flow. If suppose that does not start, cooling water start, then what will happen? Non-flow alarm will be uh, it will it will indicate that it will give an alarm, and it will trip the compressor because there is no water in the jacket. Motor overload trip, unloader. When you start the compressor, it should be in unload condition, so that the required starting current is less. As well as when you stop the compressor, that time it should be in unloaded condition, and then it stops. Low Lubile low pressure alarm, and then low pressure alarm and trips, and intercooler and aftercooler drain valves. So intercooler, many cases we use the unloader, intercooler, aftercooler drain valve as a unloader, because when you start it, when you stop the compressor, before stopping, the unload means the intercooler and aftercooler drain is open. After that, it means when you are in stop condition, both the valve is open. When you start it, compressor, your drain is open. And once the drain is open, it is in unloaded condition. And after that, after suppose the 10 seconds, the when the starting current, high current is required is reduced, after that is changeover, means the normal RPM it comes to, then the intercooler and aftercooler drain is shut, and once it is shut, then it comes on load. And intermittently also, it is timer based, the intercooler and aftercooler drains open to drain the oil and the water which is get condensed in the intercooler and the aftercooler, which has to should not carry over, which that's why periodically the aftercooler and intercooler drain on the timer, based on timer, it opens and it shuts. It's open for 5 seconds or the 10 seconds, and it shuts again.
Chief,
Yeah, tell
Chief,
me. Yeah, tell me.
I didn't get an idea about the unloader. Can you explain more?
Yeah, unloader means there are, you can have the uh, drain, intercooler aftercooler drain also is used as an unloader, but you can have separate unloader. Separate,
Excuse me,
yeah,
with the arrangement, if it is
yeah.
possible, explain with some drawings in the arrangement.
So it is like this. So you have the valve plate. This is the suction valve plate, and the suction valve will have the spring at the bottom. And this is the cylinder side. When cylinder pressure is less and atmospheric pressure is on top. So when cylinder pressure is less than the atmospheric pressure, then the valve will open against the spring. Now what will happen? You have an arrangement here. There is a piston and there is a push rod. Uh, so what will happen? There will be push rod. I am just showing in one plate. This push rod, there is a spring. So when it is in de-energized condition, this unloader, then what happened? This push rod is moved down because of the spring, and then it keeps the valve open. So suppose this is the seat. What will happen now? This is in open condition because this has pushed the valve in open position when it is de-energized. So whenever the compressor is stopped, what will happen? This piston will move down and it will open the inlet valve. Suction valve is open. Now if you start the compressor, what will happen? When piston is moving down, then the suction will take place. But when piston is moving down, or moving upward direction, then the air will not get compressed, air will come out from the suction. So there will not be any delivery. And if there is no delivery, then what will happen? The second stage will not have any air. Second stage also will be unloaded. So the first stage and this is called unloader. And you have this piston have a space at the bottom. And there is a connection through which air is coming into this side from the delivery, and there is a solenoid valve here. When this solenoid opens from the delivery, the air is coming here and move the piston upward direction. When you start the compressor, it is in unloaded condition. After 10 seconds, this solenoid will get energized and the air will push the piston upward direction against the spring. Then the suction valve will work normal because suction valve will be in closed position, and due to the pressure difference, suction valve will open. So the compressor will have it will be in a loaded condition. Clear at this office?
Yes, now on board, I saw one component on the compressor, which is called unloader, and I have some 3-pipe connection to the other parts. So that's why I asked, and it's clear now.
Yeah, you can have this kind of, but most of the cases the drain is used for the unloader, but you have this also. So now the effect due to the less clearance, the bumping clearance. Yeah, Mesfin, tell me. Mesfin, you are coming broken. Can you text me?
Safety.
Mesfin, repeat it because I could not hear you. You are coming.
Yes, Chief.
Tell me now. You are clear. Tell me what is the question, Mesfin.
Yes, if there is a non-returnable when the discharge side.
Yeah.
Yes, Chief.
Yes. Purpose of it, when you are using more than one compressor for filling to your cylinder
So
receiver.
can we consider this as a safety?
Yes, it is as a one of the safety you can consider, because when you are using more than one compressor, there will be a non-return valve in the discharge site. So that suppose one compressor is running, then it should not go to the other compressor. So that is also one of the safety you have for the non-return valve you have on the delivery side. So now the bumping clearance, the clearance volume or the bumping clearance, that is space between the top of the piston and the cylinder head of a compressor. And a clearance is important aspect of the compressor, because efficiency, it has to have a clearance because of the interference, mechanical interference. So practically, actually, because of the clearance, you have the less volumetric efficiency. And clearance volume, if it is too less, then also problem. Too more also will be problem. It affects the efficiency of the. If it is less, efficiency increases, but it can touch the cylinder line, cylinder head, and it can have the mechanical damage. So, and this clearance you need to check regularly at regular interval. It has been checked. Small clearance volume, what will happen? Piston will bang onto the or collide onto the cylinder head, and the compressor will get damaged, especially when it is unloaded condition. Why it is so? When it is in unloaded condition, whenever the drain is open or when you start the compressor, when you end the stop the compressor, it will be in unloaded condition. Then what will happen? There is no pressure on top of the piston. Then the problem is you have the bearing clearance. So here you will be having the bearing clearance. Now in that condition, there is no pressure from top. So what will happen? The piston will try to move away from the crank pin because of the centrifugal action. So what will happen? Because of the inertia action, it will be like this. And then what will happen? It will move more than when it is loaded. So it can hit the cylinder head. So that is most means that is the most dangerous situation when it will. That's why if the clearance is become high when it is unloaded condition, what will happen? It can touch the cylinder head and there will be damage. And when it is running in unloaded condition without any resistance, the movement of the piston will be more upward direction and it can hit the cylinder head. Clearance is large, then what will happen? The less air will be drawn inside the cylinder during the suction stroke. We have seen that. So what will happen? The volumetric efficiency will reduce, as well as the temperature also will increase, because the mass now after the compression will remain more. So what will happen? That will have a high temperature that has not gone out from the compressor. Intercooler we are cooling, but that is not cooled. Only the jacket water, whatever heat is been removed. So the compressor will run longer period than the necessary to compress the pressure. Now bumping clearance, how do you check that? You put a lead wire or lead ball inside the piston top, and then on the piston top you keep that, turn the compressor in one revolution, and you keep that in uh, uh, such a position so that you get the, I mean, it when you turn it, it means uh, it will get compressed by the cylinder head and the piston. And after that, the lead ball you remove, and then you check with the vernier caliper what is the minimum thickness you have got. That is the clearance volume, and the manufacturer's value you compare whether it is in correct value or not. If it is not, you can adjust it. If it increase, you can adjust it by shims. So the cylinder head also, cylinder head has got a gasket that you can do it from there. And also the if at increased you want it to reduce, then you can put the shim on the onto your bearing on the site. You can put shims, or we can put shims on the cylinder block, between the cylinder block and the suppose it is less, then cylinder block and the crankcase you can put the shims. So the gasket thickness you can adjust. Suppose it is less. Usually how you do the cylinder head and the cylinder block gasket thickness we adjust, as well as the bearing shims. It is in two half bearing, so you can put the shims in between, so that you can reduce the it will move up the crank connecting rod, and the piston will move up, and you will get the less clearance. Now the fault and remedies. Abnormal sound around the cylinder. What can be the reason? From the cylinder when it is coming, it is the top part is the problem. Ingress of foreign matter into the cylinder. An own cylinder and the larger clearance against the piston. So the piston is moving sideways, and defective cylinder head gasket. Then also you will be having the abnormal sound. And then damage air valve plate, and the spring is damaged, that will make the sound from the top side. Abnormal sound in the crankcase, wear of the piston pin bush is increased, main bearing wear down, and the rod metal also it's been wear down, piston rod metal, and the connecting rod bolt has become loose. Then you have the it will from the crankcase you will have the sound. And high temperature on delivery, then what can be the reason? So damage delivery valve or the leaking, then the temperature will increase, because what will happen then, suppose delivery valve is damaged, then during the suction from the delivery, the air will enter with high temperature, and the temperature will increase in the cylinder during the compression. Back current due to the faulty valve gasket, valve seat gasket, suppose it is leaking, then what will happen? From air from the delivery side, hot air will enter into the cylinder during the suction, and there will be a back current. Carbon deposit on air valve. Suppose the carbon due to the temperature, your oil, suppose your oil makes carbonaceous, and then carbon deposit is made on the valve, then what will happen? Valve will not completely close, and the hot air from the delivery side will enter into the cylinder, and the delivery temperature will increase. So defective cooling and decrease of cooling water quantity. Suppose the cooling water quantity is less, or defective cooling, there is a scale formation inside the jacket, or the cooling water temperature itself is high, then your high temperature delivery temperature also will be high. Too much carbon deposit, the large consumption of oil. Oil consumption is high, then what will happen at that temperature? That because it goes for the cylinder lubrication, and that temperature it will get carbon, and then carbon deposit will be made on the line. As the first thing will be on the delivery valve, because the temperature is high. After that you will see that the other parts also having the carbon deposit. Oil is not proper, it means the grade is not correct. By mistake somebody filled up other oil, because that compressor oil, it is P100 we do use, that is the at flash point is high, because at that temperature of the after compression it should not get burnt out. And then deterioration of the oil because of aging. Pressure does not rise. What can be the reason? If the pressure does not rise, then what will happen? It will take longer time to fill up. So leakage on the pipe. Maybe the delivery pipe is leaking. Damaged air valve. Air valve is damaged, so that the capacity of the compressor is reduced. Clogged suction filter. Suction filter, if it is clogged, then what will happen? Less mass of air will enter during the suction. in the LP, and less mass means the capacity will reduce. Then a defective operation of the unloader. Suppose the magnetic unloader valve is open, it does not close, then it will take more time. High clearance volume. Clearance volume has increased because of the warning out of the parts. Then you will be having the volumetric efficiency will reduce, and you will be having the more time it will take, because it will take pressure will not rise the way it should rise. Then high clearance volume, then piston ring and the liner got worn out. Then in that case you will see that your crankcase is pressurized. Volumetric efficiency is reduced. So these are the cases of the compressor does not pressure does not rise, and it takes more longer time to fill up the bottle. And if it is longer time to fill up the bottle, another thing you must check, that is the bottle drain valve may be leaking or open. Oil pressure does not rise. So the reverse rotation of the direction. Suppose after the maintenance, the compressor is running in opposite direction. A defective pressure gauge, maybe pressure gauge is defective. Clogged oil filter, clogging of oil screen, and the insufficient oil. Oil level has dropped. Ingress of air into the oil system, and worn out metal, that is the bearing metal is worn out, and the clearance has increased, pressure will drop. Accumulated dust in the oil system. These are the possible cause of oil pressure does not rise. Amount of oil consumption has increased. What can be the reason? Wear down of the piston ring and the oil ring. So that consumption has increased means it has gone with it will mix with the air and it will go to the upper part. Wear of piston and the liner, then the more oil will go to the upper part. Too much oil quantity in the crankcase. That's why when you fill up the crankcase, do not fill up more than the normal level. Then your consumption also will increase. Excessive vibration, defective alignment, fixing bolt maybe become loose, wear down of the metal, so you'll be having the excessive vibration. Metal means the bearing metal. Ingress of bubbles into the cooling water. The cylinder head bolt has become loose. So cylinder cover tightening bolt has loose, so that you must tighten it, because through the cylinder head gasket it is entering into the airspace. Cooler pipe has corroded. It means it's leaking. Cooler pipe has leaked out, leaking, so that air is going into the cooling water site, and you will be seeing the bubbles. Seizure of the piston, ingress of foreign matter into the cylinder. That's why you should never use without filter. You should never start the compressor. And insufficient oil pressure, the cylinder lubrication is not proper. Insufficient lubricating oil to low pressure cylinder, that is the LP cylinder. Now blowout of the safety valve. Tell me what can be the reason if blowout of the safety valve. First stage is lifting the safety valve. What can be the reason?
Suction valve of the second stage.
Yeah, any other? Yeah, it is the second stage problem. That's correct. What you said, absolutely. I think Abel has answered to that. Outlet valve is, this is the first stage. In that case, second stage will lift if the outlet valve is shut. First stage also will lift, second stage will lift first. So let us see. The valve seat gasket of the second stage uh, for it is that suppose gasket by mistake has not put in the second stage valve, then what will happen? The inlet valve, the first stage air will not enter into the, it will go to the second stage, but it will come out through the suction valve. So the first stage pressure will keep on increasing, and the first stage it will lift and damage air valve in the second stage. Second stage suction valve is damaged, same thing will happen. And also if its second stage delivery valve is damaged, then also it will lift the first stage. Why? Because your first stage is delivery. Second stage, during the delivery, some air is coming from the delivery side to the cylinder. So the suction side, the pressure will get accumulated, and the first stage relief valve will lift. Inverted installation, it means sometime by mistake, if the cylinder valve is inverted position upside down, if it is assembled, this will happen also. This is a second stage problem. Now the second stage safety valve has lifted. What can be the reason? Tell me. Abel, tell me.
Maybe discharge valve closed.
Yeah, maybe the discharge valve closed. And let us see. The setting pressure of the switch, which is cutting in and cutting off of your compressor, may be wrong. It means the setting pressure of the switch may be high. It does not cut off below the safety valve set pressure. And shutoff valve on delivery pipe is closed. And inverted installation, opposite installation of the check valves on the second stage, then also it will happen, because it will not come out, air will not come out through the delivery, and the relief valve will lift. Failure of water pump. So suppose it is rusting and the freezing, and then the water pump will get stuck. Yeah, Mesfin, tell me.
Chief, one time I have experienced one thing. This second stage safety valve was lifting because of the discharge valve was closed. After maintenance, if we forget the discharge valve closed, then we'll be opening the safety valve.
Yeah, this is the second one. So the shutoff valve on the delivery pipe is closed. So then the second stage, it happens, not only in your case, it has happened sometime by mistake, because after maintenance it happens. When somebody does not open that by mistake, and then it happens. So the water pump failure, maybe the ingress of air in the water pump, and then inclusion of the foreign matters has entered into the pump, and pump has seized, or the pump is not rotating. Failure of the pump driving part, it is belt drive, so belt may be parted, so I was slipping, so that the pump will not rotate. Then failure of the water pump, then that is the one. And the emulsification of the humid environment of the setting room, it means the where the compressor is there the environment is humid. What will happen in the crankcase? The water it will get condensed, the water, and then the lube oil will get contaminated with that water. Excessive cooling on the compressor, and once the excessive cooling is there, what will happen in the crankcase? The moisture will get, it will reach to the dew point, and the moisture will get condensed, and that condensed water will contaminate the lube oil. Poor discharge of a drain generated in the compressor. So if the poor discharge is generated in the compressor, suppose the aftercooler and the intercooler drain is not correctly opening, and the water is not get drained out, then what will happen? That water will carry over to the other means the it will go to the HP side, and HP side scraper ring will bring that water in downward direction in the crankcase, and you will be having the contamination. So these are the troubleshooting for the main air compressor. Any question in compressor?
Yes, can you explain about the auto drain on the compressor, sir?
How to say again?
Auto drain.
How to drain? Are you talking about the intercooler aftercooler drain?
Yes.
Yeah, intercooler and aftercooler drain is this one. So let's refer to this diagram. So here you have this is the intercooler drain and this is the aftercooler drain. You will be having a manual drain and you will be having an auto drain. This is solenoid control. So in this is timer based. So it knows, suppose every after 30 minutes it's open, or 15 minutes is open for 10 seconds or 5 seconds. So whatever is getting accumulated, it is, since it is timer based, you have say timer setting, and at that time interval it will open automatically, and in the air is passing through this. Air is the shell fluid and the water is the tube fluid. So what will happen, the water and the oil will get accumulated at the shell, and through the drain it goes to the your drain of the compressor tray. Has got a drain, it goes through that, and it goes to the bilge holding tank or the bilges it goes to.
Yes, it is. But
So
can you explain more on inside internal arrangement of the auto drain internal structure?
so this solenoid valve you mean to say, correct?
Yes.
So yeah, solenoid valve, you have a core, you have a coil, and you have a diaphragm, and this diaphragm there is a valve, and this is the valve seat. So there you will be having the spring. This will be spring loaded. So with that spring, what will happen? The diaphragm will be in upward direction and it is in closed position, because this will be in closed position. When this coil is energized, then this cord will move downward direction, and then it will push against the spring, this diaphragm, and this will be in open position. So this is the internal structure, and this is the inlet and this is the outlet. Or this is the inlet and this is the outlet. Because this pressure, because this line is pressurized, so this will be in closed position. Only when with the spring force, as well as otherwise what will happen, if it is that this direction, then the valve is always loaded, it is trying to open, so it is at the bottom, and this is the outlet. Is it clear?
Yes.
So now let us take a coffee break for 20 minutes. So at 10:22 we'll restart again. So good morning once again.
Good morning to you.
Let us start. So next is hydraulic system. So the hydraulic system we do use on board the ship. And let us see the component of the hydraulic system. So what are the basic component for the hydraulic system? Hydraulic system, that is the power is transmitting uh, by it employs the pressurized liquid as a fluid to transmit the energy from one part. What happened? We have the pump. Pump is driven by the electric motor, for an example. So the energy is added to the fluid, the pressure is increased, and then that pressure is transported from one point to the other point where the work has to be done. And the energy, that is the energy generating source, that is the pump, and the energy using point, that is where the work is done by the system. Energy is added by the pump, that is work on the system. So then the useful work is done. Let us see the simple circuit of hydraulic system with basic components. So for the hydraulic system, we need a reservoir, that is the oil tank. For pneumatic system, we can, like the return line is not required. We have a reservoir, that is the stored energy, and then we supply to do the work, and after the work done, it released to the atmosphere. But whereas for the hydraulic system, we have the reservoir where the oil is stored, and the return line has to come back to the oil, has to return to the reservoir back. So now, first thing, from the reservoir, there has to be a filter, because the particle which is coming to the any contaminant which is coming to the reservoir should not go back to the system. So we have the filter, suction filter, and then we have the pump, which is driven by the motor in this diagram. So what is happening? The motor is driven by the electrical energy. So we are adding the energy to the system, that is the fluid, that is the hydraulic oil will increase the pressure, and filter will mechanically separate the contaminant, the particles from the oil. After that, there will be a pressure regulator. Why do you need pressure regulator? Because we need to, every system has got a pressure, working pressure. It has to maintain that pressure. And also when the pressure increases for some reason, so that it will lift and then it will maintain the pressure. Excess pressure will be released. And after that, there has to be a direction control valve. Why do you need direction control valve or the flow control valve? Because the piston or the motor, suppose it is having a reciprocating motion to do work done, then what will happen? The direction has to be changed. Sometimes the piston will move upward direction in this diagram, sometimes it will move a downward direction. So to change the flow direction, you need to have a direction control valve. And after that, you have the actuator. Actuator is doing the work. So the work done by the system by the actuator. So the actuator, suppose in this case, the load is lifting and lowering by the actuator. So bottom of the, there is a piston and a cylinder. So bottom of the piston, when it is getting pressurized, then it is moving upward direction. And when the pressure is from the top and bottom is drained, then it is moving downward direction. After that, it goes to the back, the return line, it goes back to the reservoir. This is the basic component of the hydraulic system. So if we see this, diagram, so the flow will be like this. This is the reservoir, and this is the filter, and you have the pump, and you have the pressure regulator, and there will be a connection to the return line. This is a block diagram, that's why it is not shown, because the excess pressure, and there will be a spring here. So what will happen once the valve pressure is high, then what will happen? This spring force is in downward direction, and this pressure is an upward direction. So once the how much it will be open, it will depend on the pressure will be maintained at this point after the pressure regulating valve, so that this is suppose this is let it be like this. So this is the pressure regulating valve, only it is maintaining the pressure on the system. And you can have a pressure regulating valve with the relief valve, so that it will be connected to the return line, and it will be spring loaded. This also will be spring loaded. And after that, three-way valve is like this. It means in this position, this is, suppose this is A, this is B, sorry, uh, this is A, this is B, this is C, and this is D. This is 4-port, 3-position valve. So when it is on 1, then what will happen? This 2 will be connected, and this 2 will be blocked. So it will locked in this position. Now when it is in 3, then what will happen? The on 3 position, it will change to, suppose this is in 3. So this 2 will be connected, and this 2 will be connected. So what will happen? This is drain, and this is pressure. This is return line. So the piston will move in this direction. And when it is 2, then what will happen? This will be the connection. So in this case, this is the pressure line, this is the return line. The piston will move in upward direction. So this is the basic component of the hydraulic system. And for the pneumatic system, there is no return line. It is not required. This will vent out to the atmosphere. And the only thing, there will be a filter, sinter filter. Because when it is coming out, oil will carry some oil. Oil should not come, which is causing the health hazard. When it releases to the atmosphere, there should not be oil coming out. A hydraulic actuator device, we have seen, that converts the fluid power into mechanical power and do the useful work. And the actuator, it may be linear. In that case, what I had shown you the diagram, it is linear, but it can be rotary also. For an example, the valve, suppose you have the actuator which is linear motion, and it is opening and closing the valve. So that is suppose it is a watertight door. It is hydraulic cylinder, or let us take it as a steering ram. Steering ram, it is hydraulic power. So ram is linear, having the linear motion in the cylinder. That is the cylinder, and the useful work is done. That is mechanical power. From the fluid power, it goes to the mechanical power. And it can be actuator, can be rotary type also. For an example, windlass, mooring winch. Suppose it is driven by the hydraulic motor, then it is a rotary hydraulic motor. It means this rotary type, the actuator. And it provides the linear and the rotary motion respectively. It depends upon the application we use that. So hydraulic pump is we are using for to force the fluid from the reservoir to the rest of the hydraulic circuit, because it has to go from the reservoir to the rest of the hydraulic circuit and with high pressure, and it converts the mechanical energy into hydraulic energy. The pump is doing that. And the valve we are using for the control, the direction control, we have seen, and we have used for the direction control valve as well as flow rate or the fluid flowing through the circuit. So pressure and the flow rate is adjusted, flow control valve, the pressure control valve. So the flowing through the circuit, how much flow will be, what will be the pressure maintained. That's why we have the pressure valve, that is the relief valves, or the pressure regulating valve. We have the flow rate control valve. Now external power supply, that is the motor, which is driving the pump. That is uh, that is the external power supply. We use on board the ship. We use the electric motor. We can use the engine also, like Framo system. Many of you might have seen those are worked on chemical tanker. The Framo, some of the pump is driven by the engine. That is the hydraulic pump. Now the reservoir, it holds the hydraulic liquid. That is the hydraulic oil. And the piping system, it carries the hydraulic oil from one place to the another. And the filter, it removes any foreign particles to keep the fluid system clean, because hydraulic system does not go wrong if you can maintain the hydraulic oil properly. Because if hydraulic oil gets contaminated, then it gives start giving a trouble. It gives very large trouble. So the fluid system has to be kept clean and efficient, so that avoid any damage to the valve, damage to the actuator. And that's why all the hydraulic system, you will see that in this diagram, it is not shown here. So there will be a return filter. So this is the return filter. So that there will be wear and tear, that should not come to the reservoir. There is a magnetic filter here. Always, all the system in the uh, on board the ship will see there is a return filter. Now, the pressure regulating valve, which maintain a required level of pressure in the hydraulic fluid in the system, because a different system will have the different pressure to be maintained. So it regulates the pressure. Then the piping, what you have seen in this diagram, it is a closed system. It means it goes to the reservoir. From the reservoir, it comes back to the reservoir. So it is a closed system. And fluid transferred from the storage tank to one side of the piston, and from other side of the piston, fluid comes back to the reservoir. And the fluid is drawn from the tank by the pump. It produces the fluid flow to the required level of pressure, and fluid pressure exceeds the required level, and excess fluid return back to the tank, remaining where pressure required once it maintain the required pressure. That's why the pressure regulating valve, I had drawn a line which is connecting to the return line. So excess oil will come back to the return line and going back to the reservoir. Now, what are the advantages? The hydraulic system has got advantages. Large load capacity, where you require the you require the hydraulic system. The pneumatic system, you cannot have the large capacity, whereas hydraulic system is large capacity, because air is compressible. The hydraulic oil is not compressible, so it can have large capacity. And high accuracy, if you want, you will be going for the hydraulic system. It is high accuracy and precision. So it means in the movement, it's very precise. So you have the hydraulic system. Smooth movement, hydraulic system is smooth movement. Automatic lubricating provision to reduce the wear, because the hydraulic oil itself is a lubricant. And everywhere inside the system you have the hydraulic oil, so the wear and tear is very, very less. Division and the distribution of the hydraulic force are easily performed. So that division and you just put a pressure regulating valve, different pressure you can supply to the different distribution system. The hydraulic force easily it can be performed with different pressure, and limiting and the balancing of the hydraulic force are easily performed. So the you can limit the pressure, you can force limit, you can have the time delay, that is you can have a throttling, so that the time delay you can reduce, means introduce, so that the movement of the actuator you can control. And also with the valve, where you move the valve, suppose this is the extreme end, this is the neutral, and it will be always spring loaded, so that when you release this handle, it will automatically come back to the, with the spring force, it will come back to the neutral position. And suppose 3 you move up to here, so the speed will be reduced. As you move in this direction, the speed will increase. As you move in this direction, speed will increase. So how much angle you have moved, it means how much passage you have given to connect the inlet and outlet. So the pressure will be accordingly, the flow will be accordingly, your speed also you can adjust. And this disadvantage, the machining, the machine, the elements are machined, the clearance is very fine. So it is machined with high degree of precision. And leakage of hydraulic oil can be a problem for the operator, can slip. And the special treatment has to be needed to prevent the rust, corrosion and dirt, so that that should not be there in the system, otherwise leak will start. And the dirt and rust, when it forms, then what will happen, there will be, these valves are very, very fine clearances, it will get stuck. Hydraulic oil may pose problem for aging and the chemical deterioration it can have. And hydraulic oil can be messy, that is a, around the, when there is a leakage, what will happen around the area, everywhere you will be having the oil, and it can be a fire hazard also. So these are the disadvantage, these are the advantage of the hydraulic system. Any question? This is the, like you can, you have studied already the steering gear, that is also hydraulic control system. That also has got a reservoir, it has got a pump, it has got a pressure regulator, it has got a direction control valve, it has got an actuator. So these are the basic components you need to have for the hydraulic system. Now the next is fuel oil system. Fuel oil system is in the general, and it can be, some question can be asked in motor also, because it comes under both. The fuel oil system, the bunker line, we have the manifold. This is the upper deck, this is the main deck, and you have the manifold, port and starboard. And then you have the filter, and then you have the pressure gauge. Because manifold pressure you need to know. Temperature. At what temperature you are receiving the fuel. You'll have to calculate the mass finally, how much mass you have received. Then you have the flow meter. And you have the flow meter bypass. Always flow meter will have a bypass and flow meter will have a isolating valve. After that it comes here. And then it connects to the different line, different tanks. So for an example, it goes to the dip tank. And a dip tank will be having a level indicator and will be having a level switch so that it can triggers the alarm. And then the next line which is going to the dip tank number 2. Suppose this is number 1 dip tank, this is number 2 dip tank. This is number 1 DV tank, this is number 2 DV tank. So the third line is going to the DV tank 1. And then fourth line it is going to the DV tank 2. So in this diagram you have the 2 DV tank, 2 dip tank, and you have a overflow tank. Always overflow tank will have a high level alarm. Always. And the bunker tank will be having the level indicator which will show how much is the contained. But overflow tank will have a low level, with the level alarm, that is a high level alarm. And if you see this, this is the overflow line. It is a requirement of the IMO. So this all connected to the, all 4 tanks are connected to the overflow tank. And then it is going to the overflow tank. An overflow tank will have a vent. Or each tank will have to have a vent. And this, the line which is going to the overflow tank, there is a vent. So this is the bunker line. Bunker line, so we receive the bunker from the supplier and we put it in the storage tank. And from the bunker tank, we transfer to the settling tank. But that transfer pump has got some other duty also. So this transfer pump, one job it does, it supply to the settling tank. It is going to the settling tank. But it does something else also. Internal transfer of the tank also. It means this suction is connected to all the tanks. It can take suction from all the tanks. As well as the delivery, it goes to the all the tanks. It means your pump will have a number of valves. This is the suction valve, and then it will have so it will be connected to all the tanks. So it will connect to the all the tanks. It will take suction from all tanks. At the same time, the delivery will also go to all tanks as well as the settling tank. And this delivery will be through the bunker line. There will not be any separate line. It means it will be, if you take suction from one tank, you will be able to supply to the other tanks. And also this delivery is connected to the this line, filling line. Suppose your tank is, this tank is, oil is contaminated, you cannot use that oil. You need to debunker it. We call it debunker. For debunkering, we use our pump. The transfer pump you should be able to use. So there will be a line which is taking suction from this tank, and then delivery is connected to this. So this oil will go to the manifold. And in the manifold, the line will be connected to the barge or the terminal. So it will go to the shore reception. It means we can debunker to a barge or terminal. You can, with the manifold on the jetty, you can transfer this oil from the ship, because you cannot use that bunker. So this is the bunker line you have. And now the fuel oil treatment, which means we have received the oil in the bunker tank. Now fuel oil treatment from the storage tank to the engine, how, what system you have. Now the various piping system will be having for the fuel oil. One, we have already seen the bunkering line, that is storage, and then it is transfer line will be having, because bunker tank from bunker, internal transfer to the bunker tank, or we have seen that it can discharge to the for debunkering purpose also. And then transfer line, that transfer line only does that also, and then transfer to the settling tank also. It can do the offloading of the bunker, and then treatment of the fuel oil. There is treatment line. So you can divide the fuel oil line into fuel oil transfer pump after the bunkering, fuel oil transfer system, fuel oil treatment system, and fuel oil supply system. So the transfer system, so oil we have seen it receives in the storage tank, and then it is stored and then delivered to the settling tank. And for this transfer system, it delivers to the settling tank, as well as fuel oil loaded through the deck filling connection. There has to be a sample line, so that the fuel sample can be taken during the bunkering. And HFO is loaded to the storage tank, which is fitted with a heating coil. Why the heating coil is fitted? So that the use of HFO transfer pump, that fuel oil settling tank, it will be transferred to. So it has to maintain certain viscosity for the transfer. That's why the heating coil is provided in the storage tank. And the suction side of the pump will have a strainer where the particle, it will be a coarse strainer, so where the particle, large particle will be separated in the suction strainer. And the pump pipe is arranged so that pump can transfer fuel between storage tanks and to the deck connection, as I told you, for the offloading of the bunker, and to the settling tank, which is used to permit the gross water, and it will go to the settling tank also. So where the gravity separation will take place, and the gross water and the solid to the it gets settled at the bottom. We maintain at higher temperature, so that the gravity separation time is reduced. For better separation, we increase the temperature around 50 to 60 degree centigrade in the settling tank. And from the drain at the bottom, we remove this water and the solid which is settled at the bottom. Now the settling tank fuel oil, which will be transferred to the service tank via fuel oil treatment system, that is the treatment system. And for cleaning of the heavy fuel oil, we use the two-stage process commonly used. What are these two stage? Fuel is heated in the settling tank about 50 to 60 degrees centigrade, and then the purified inlet pump or the feed pump, it takes suction from there, and inlet pump, it's delivered fuel uh, thermostatically controlled heater, which will increase the fuel temperature to about 80 above 80 degrees centigrade. It will be around 98 degrees centigrade what you use for the purified, and then it goes to the centrifugal purifier, and the dry uh, purified oil then transferred to the between purified, first is purified, that is water is removed, the liquid is removed, then it become dry, it has got particle, and then that dry purified oil is transferred to the centrifugal clarifier. Once it goes to the clarifier, by the purified discharge pump, it is in series. It's talking about. Then what will happen? After clarification, the clarifier discharge pump delivers to the fuel oil service tank for the engine use. It means in clarified dry oil, there are particle. That particle is been removed, separated in the clarifier. Then the system supply the fuel from the service tank to the diesel engine. Now what you have in that, the flow meter you have, then you have the supply pump, circulating pump you have the preheater, because before the engine, the viscosity has to reduce to 13 CST, so there will be a preheater. And then you have the final filter, that is the fine filter before the engine, and then viscosity controller and the fuel oil vent valves. These are the, because those particles which cannot be separated by the centrifuge will be filtered out by the fine filter. And the pressurized system is preferred. Why? The reason being, the pressurized system is preferable while operating the diesel oil on high viscosity fuel, with diesel engine on high viscosity fuel, because the temperature will be maintaining high, so it should not get vaporized. So the pressure has to be used high pressure. So this is a unit you have. All the modern engine, modern ship, they use the module. This is a module. It saves time, as well as it complete module comes from the makers, and the shipyard, they install complete module. They only connect the pipes. So it saves drastically, it reduces the time. And let us see this. This is the double bottom tank, which has got the heating coil, and this is the suction filter, and then you can have the suction filter here, and then pump is delivering, the transfer pump is delivering to the settling tank, but it does other transfer also. And then settling tank 50 to 60 degree you maintain. You have the drain, through the drain you remove those impurities, water and solid, and then it goes to the centrifuge pump, that is the feed pump. It goes through the heater, it around 98 degree it increased to, and then it goes to the centrifuge. First one is the purifier, and then it is the calorifier. So the water liquid is been removed in the purifier, then the dry oil goes to the clarifier where the particles been separated. After that it goes to the daily tank. And daily tank also you have the heating coil, you increase the temperature, you maintain the temperature around 98 degrees centigrade, because purifier is supplying at 98 degrees centigrade, but whatever is losses, that you make up with this heating coil. And after that, in the daily tank also, or the service tank also, there will be gravity separation, and the water and the solid will come out, if any water carry over, and the solid, and then it goes to the flow meter, and then it goes to the mixing column. Suppose this engine is driven by the uh, your, like there is no it is not recirculation fuel valve, what I had explained in one of the diagrams. So then you don't need this booster pump. Here you can have the booster pump here because there is no need of circulating pump. But the moment you have the return line from the fuel valve, it comes to the return line from the pump. So these are connected, all are connected in that case. So then it is, you need a circulating pump. So there will be a circulating pump. Sorry, this is a supply pump and this will become circulating pump. So circulating pump in that case will take suction from the your mixing column, and mixing column you have a cooling coil. Many cases you have that. It is not the heating coil, it is the cooling coil. Why? Because the return line will be very high temperature, and in mixing column it can vaporize, and then that will be, it will go to the vapor trap and it will go to the atmosphere through the vent. So what we do actually, you have the cooling coil which reduces the temperature and then it gets condensed so that you don't lose the oil, and the temperature also it does not increase excessively. And after that the circulating pump is taking suction from the mixing column, and then it goes to the this pump also will be having the filter, and then it goes to the heater. After that it goes to the viscosity controller, and then because the viscosity has to be 13 cst, around 10 to 20 15 cst, and then it going to the fine filter, that is the hot filter. This is the hot filter, this is cold filter. And the hot filter, the size of the mesh is in micron, 10 micron we do use, and if the impurity is too high, then we use even 5 micron. So in this one you use around 150 micron, because cold filter you cannot have the less micron, then it will get choked. So the hot filter is always is the less micron we do use. And then return line, there is a pressure regulating valve, it comes back to the your mixing column, and it can go to the, there will be another line which is going to the service tank. And this pre-warm bypass, it means when you start, suppose you have stopped the engine, then but in this case the return line for the fuel injector, if you have, then what will happen, you are not stopping the circulating pump, so the high temperature oil is always flowing through this, and that moment we don't use that high temperature. It means we can reduce the temperature slightly in a port, because our intention is to not the injector get stuck, because it is not atomizing at that point. So around 80 degree we do maintain in port, or 90 degree we do maintain, so that it maintains the temperature throughout the system, so that the nozzle does not get stuck when you restart it. Now the purpose of the treatment, yeah, Ameswin, tell me.
Yes, Chief, can you explain one more time? Because I don't understand the part that we don't have a supply for the supply pump because of, yeah, you explained one reason, but.
So suppose you you don't have recirculation fuel injector. In that case, what will happen? Whenever you go to the port, you during the maneuvering, you change over to diesel oil. So in that case, you don't need a supply pump. But the moment you have the recirculation valve, then what will happen? You will be having two sets of pumps. One is the supply pump, one is the circulating pump. Because circulating pump, you won't be able to stop during the port stay. Because port stay, you will be you will be stopping the engine on heavy oil. You will not change over to a diesel oil. If you have diesel oil, change over to diesel oil, then what will happen? You have already changed over to diesel oil. You don't have to run the booster pump. Booster pump is only the increasing the pressure to the required pressure. And then you can use at sea, you change over after departure, after RFA, you change over to heavy fueler, because after that you will not stopping the engine, you will continue moving the vessel. And when you reach to the standby, then you start changing over from heavy oil to diesel oil when arrival port. So in that system, you don't need the supply pump. Supply pump will not be there. It will be this system what you have seen in the diagram. But in all modern ships, what you will have, you'll be having the supply pump and the circulating pump. Uh, is it clear? In that case, you'll be using the diesel oil during the maneuvering and when you stop. And for this, there will be a pre-warming bypass valve will be having, so that the when you use the booster pump, then the heated filter has to be uh, heated. The return line will go through the heated filter, because what will happen otherwise, the the filter will get choked, because when you start that heavy oil, that time you uh, use means you can preheat the uh, you can bypass this heated filter, because filter will be get choked, and then it will go to the return line and going to the your mixing column. So this will bypass your, because engine is not running that time, so it will bypass your means the hot filter as well as the pressure regulating valve, and it will go back to the uh, this. So this is the bypass valve. And another thing, there is a drain here. So mixing column, if required, suppose you want to drain the mixing column, you can drain it, and that goes to the drain tank, the fuel oil drain tank, or it goes to the fuel oil overflow tank. It is connected. It is a closed system. It cannot be open system. The Mesfin, is it clear what you asked or something else you asked?
Yes, Chief. I have system with the boss diesel oil was choking, and can you explain the reason also for the filter to get choked?
Yeah, the hot filter you are talking about.
Yes, Chief.
Hot filter will get clogged because if the viscosity is high, temperature is low means viscosity is high. Then what will happen? Your hot filter is 10 micron. It will get choked because the viscosity of the or the density of the oil is very high. As the temperature, suppose you are maintaining 130 degrees centigrade, 140 degrees centigrade, what will happen? Your viscosity is less, it will become light. The small hole, through the small hole also, the oil will pass through. Because 10 micron, because when the temperature is less, it will get clogged because the viscosity is high, so the density is high, the size which is passing through, it can only pass the 10 micron. Larger than 10 micron, it won't be able to pass, so that the quantity will pass through the filter will be less. So that's the reason it is called hot filter, and it is fine filter is always hot filter. Whereas suction filter is 150 micron, it is coarse filter, because at that point the temperature is less. So, but the flow you need to maintain, you cannot restrict the flow. So that's why accordingly the filter size is put. Is it clear, Meswin, why the filter
Yes,
gets choked, hot
yes, sir.
filter?
Yes, sir. As I'm understanding, uh, the heavy fuel oil in the filter will get cooled by the cold diesel oil, and then will get stuck in the filter. Yes.
Yeah. So when you are changing over, that is.
Yes, Chief.
So the why do you treat the oil? What is the purpose for it? fuel oil treatment requirement in order to improve the operational safety of the vessel by increasing the reliability of the oil fueled machinery, because the combustion will be better and the damage to the engine also will be less. It means the wear and tear will be less. The performance should be such that the system and the equipment contained in the fuel oil treatment, the fundamental what it does, it reducing the level of contaminant, because oil has got the contaminant, that contaminant is reduced, and oil filled machinery will bring to the manufacturer specification, because manufacturer will tell how much should be the level of contaminant. For an example, cat 5, the manufacturer says it should be less than 15, 1.5. But whereas if you see the ISO requirement, IMO requirement, as per the ISO, uh, it is 8217, it is the 60 is the limit. So the supplier will supply within maximum 60, but the engine maker says that it should be less than 15. So up to 15 it says. So it means you'll have to treat such a way that the cat fine should come out from the your fuel oil so that your machinery is safe. So it is the manufacturers of the machinery, their instruction we need to follow. Fuel supplied to the ship must be treated on board before it is used. So the in order to remove the solid impurities as well as the liquid contaminant, and solid contaminants in the fuel are mainly sand, rust, dust, sodium, vanadium, then refinery catalyst, that is the cat fines, that is the aluminum, silicon, and then liquid compound contaminant is mainly fresh water or the salt water. And all these things we need to remove for better combustion, so that the ship engine is safe, ship is also safe. The settling tank in the first step of the treatment process, and water and the sediments are separated by gravity, and it is drained off at the bottom, and it treated at high temperature, around 50 to 60 degree centigrade. Effective cleaning of residual fuel can only be done by the centrifuge. That's why the centrifuge is most important, the effective cleaning. We have the clarifier to separate the particle, and purifier separate the liquid or the water. And to remove the solid particle not separated in the centrifuge, because there will be some particle which won't be able to separate by the centrifuge. In that case, how will you, because that will carry with the oil to the system service tank, then how will you remove that? By using the fine filter. We use the fine filter which is placed directly after the centrifuge or in the supply line or the service line from the service tank to the engine. So this is the way, this is the reason for your treatment, and if you don't remove this contaminant, what will happen? There will be engine component will get damaged, and there will not be proper combustion. For an example, the cat fines, when it enters into the, once it enters into the engine, cat fines, the engine you cannot protect then. The engine will get worn out very fast, and your piston ring liner, you'll have to, it is so hard, cat fine, it gets embedded onto the surface of the liner and the piston ring, and piston ring, piston crown, piston ring, and the liner surface will get deteriorated, and you'll have to change the liner, piston crown, piston ring has to be changed. So then it is, and it will depend on how much quantity it is going to the engine. You'll have to replace all the unit or what I told, which will be affected. Now you'll see if you have the cat fines, the main engine will get affected first, faster than the your diesel generator. Why? Tell me. And in worst case, your fuel pump also will get, because there are fine clearances within that, the cat fines will enter, and you will be having the damage to your fuel pump also, and fuel valve also will get damaged. So now tell me why the two-stroke engine, because you are using the same fuel for generator and the main engine, but main engine will be affected faster than the before than the generator. What can be the reason? Because if you have the splash lubrication for the cylinder liner for the generator, then what will happen? It is splashing onto the liner surface, and it wash out those particles. That's why the splash lubrication is better. But thing is that then why do you have the dry sump? Or many generator you have the dry sump. Why? Because of the crankcase explosion. To avoid the crankcase explosion, we have that. Otherwise, splash lubrication is better. A cylinder oil lubrication, this particle does not remain on the surface. It will get washed out by the splashing. So, any question? What we'll do now, this the remaining general portion of the auxiliary machinery, there are very little is remaining. That we'll do in the next class. I'll start now. We have time, 45 minutes. I'll start the motor now. I'll give you 5 minutes break, and then I'll start EKM. So you take a 5 minutes break. Exactly after 5 minutes, that is 48, not 40, yeah, 48 we start, or 47 we start. There was a, yeah, let us start again. But before I start, there was a question from Abraham, that in what condition we include the hydraulic oil cooler in the return line. So, in for an example, the why it's included in the return line, because after the doing the work, that the oil will temperature will increase. So the return line we have the uh, cooler, like for windlass and the mooring winch, we have the cooler. We provide a cooler where it is cooled by the seawater from the fire line. One of the branch, it goes through that and then it gets cooled, because after the work, the temperature increases, the heat energy is removed from the system. But in that diagram, you see there was no cooler provided. In that case, how the cooling is done? It is done in the reservoir. Reservoir is a natural cooling, is the ambient temperature. Heat is transferred to the ambient in the reservoir from the reservoir surface. You can have in the reservoir also, you can have the cooling coil. Many of the system you have that. Now let us start the engine fault and abnormal. Yesterday, actually, we could not start this because of the problem. Now the scavenge fire. In the scavenge fire, it means in scavenge space you have the fire. So how it happens actually? Scavenge space of the Crossett type engine, two-stroke engine, what you have in the, that is the on top of the uh, diaphragm, that is above the diaphragm, and under piston area, that is in that space. What you have actually, you have the combustion product, that is the soot and ash, and there are unburned fuel which is not burned in the cylinder, that which is passing through the piston ring and going down to the on top of the diaphragm or under piston area. And then cylinder lubricating oil, which is unused oil, which is not used, that will means that will fall down because of the gravity, and then that will get accumulated at the bottom, that is on the in the scavenge space. And there will be dust. Dust comes from where? From the scavenge air, because scavenge air, when it is passing, that's why the felt filter cleaning is very important. The hole size should not be increased, then the particle size, larger particle will enter. And that comes where some particle will enter, because you cannot stop all the particle to enter, so that will come to the scavenge space in the air. With the air it comes, and these deposits are combustible, so it is work as a fuel in fire triangle. Now the scavenge space is a drain, and there is a drain, scavenge space drain, scavenge drain. All these deposit, what happens? It goes to the, through the drain, it goes to the scavenge drain tank. In normal condition, some deposits can remain in the scavenge space, but the deposit should be very, very less. And these deposits create the hazard of a scavenge fire. And if that deposit accumulates, and that can create a hazard of the scavenge fire. So the severity of fire depends on the how much is this deposit which is accumulated in the under piston area. Now, what are the cause of scavenge fire? Suppose from the combustion chamber, a flecks of burning or glowing carbon deposits is dropped into the oil sludge. From the top, it blow past, and then it comes to the oil sludge in the scavenge space. Then what will happen? You have air already, you have the fuel, you have the heat source. So there will be it means the sludge can be ignited, and serious damage can be done to the piston ring. So so piston rod will have the damage, can be, it depends upon how is the fire, how big is the fire. And the scavenge airbox wall also can get damaged, and possibly it will reduce the tension of the stay bolt. Stay bolt, what will happen? The stay bolt will get elongated. Once it gets elongated because of this high temperature and the pressure, then what will happen? The bolt can get, nut can get slackened, and then the tension can reduce. So that whenever there is a scavenge fire, you must check the tensioning of of your tie rod has to be done. And ignition of the carbon deposit in the scavenge air box, which is, suppose the this carbon deposit you have in the scavenge air box, that can get ignited. So suppose the prolonged blow past you have, in the slow combustion in the cylinder, then what will happen? There will be a after burning, and then it can go to the scavenge space, and then there can be a combustion of this carbon, ignition of this carbon deposit. So incorrect atomization, suppose, then unburned fuel, and then that will cause the blowpast, and then it can ignite. Incorrect type of the fuel, nozzle valve. Nozzle valve, it depends upon the type of the fuel. You have the different kind of nozzle. Suppose by mistake the ship has ordered wrong nozzle, and you put that nozzle, and then that will misalign the fuel jet, and then that can cause for the blowpast and then scavenge fire. Blowback through the scavenge air port, when it can happen, suppose the exhaust cam is adjusted incorrectly, because the scavenge port should open when the inside the cylinder pressure is less than the scavenge air pressure. Suppose the exhaust valve does not open on time, and a scavenge port open, when the scavenge port open, the scavenge pressure is less than the cylinder pressure, then what will happen? There will be a blowback of the uh, high means from the cylinder, it will go to the your scavenge space. And a large resistance in the exhaust system, suppose, that is another problem of the blowback. Suppose the exhaust piping is choked, exhaust trunk is choked, then what will happen? There will be a back pressure of the exhaust. So the cylinder pressure will not drop, because of the pressure difference is now less, because the cylinder exhaust will go out through the exhaust uh, trunking because of the pressure difference. Now there is a back pressure in the exhaust side. So what will happen? The pressure difference will reduce, and the inside the cylinder pressure will remain higher than the scavenge pressure when the scavenge port is open, and there will be a blowback. And to keep this resistance low, heavy deposit not allowed to collect in the protecting grating. The grating, what is grating? Grating is a perforated plate which is inlet to the your turbocharger. It is put so that no foreign particles can go to the turbocharger. Suppose the your piston ring, suppose it is broken, and then it can go to the turbocharger and can damage. So there is a perforated plate at the inlet, so that can get choked with the carbon deposit. Suppose it has, there is the reason periodically we do clean that grating, and that grating is get choked, then can be nozzle ring also can get choked, and the turbine blades also can get choked. Then what will happen? There is a blockage of the exhaust, and back pressure will increase, and the back pressure after the turbocharger also, that is the we check, that is the reason, or the there should not be back pressure due to the economizer also. After the turbocharger, it should not exceed 350 millimeter water column. So the periodically you clean the economizer, not only for economizer purpose, also for the engine, so that there is no back pressure is created. Now, how will you prevent this? So scavenge trunk, it has to be periodically inspected and cleaned. So any buildup of the contamination, it should be noted, and it should be remedial action has to be taken. So now what is the reason for contamination and the buildup of the sludge in the scavenge space? Drain pockets should be cleaned and clear regularly. Remove thicker carbonized oil sludge so that it does not remain onto the means and this drain passage should be cleared. It should not get choked also, because if it is thick, the sludge in the under piston area, then what will happen? The drain passage might get choked. So it should not get choked also. Scavenge drain should be blown regularly, and any passage of oil from them to be noted. If any oil is coming out through that, it means the oil is coming from top, either cylinder oil or the your fuel oil. and it has to be noted so that you know that it is something is wrong, so you'll have to do something. Then guard against the excessive cylinder oil use. That's why the specific cylinder oil consumption has been calculated always. Chief engineer calculates that so that the correct quantity of the cylinder lube oil is being used. Because excess lube oil, where it will get accumulated at the scavenge space, and there can be a scavenge fire. And timing of the cylinder injection, it has to be periodically checked uh, so that the correct timing it is been injected, so the cylinder condition will be good condition. Scavenge port are to be kept cleared so that there is no blockage in the scavenge space. If there is a scavenge port is blockage, then what will happen? So there will be the scavenging will be poured, your combustion will be poured, and accordingly what will happen? Your incomplete combustion and also the cylinder lubrication also will be failure because exhaust temperature also will increase. The symptom of the scavenge fire, what are the symptoms?
Sir, you are muted.
Yeah, tell me. FM, tell me. I think if, yeah. So the symptom is exhaust temperature of the affected unit will be high. Yeah. So this pipe should be blown through when you do the uh, cleaning of the under piston area. That time you can blow through the pipe so that you and also what will happen? You don't keep it fully open, isn't it? The scavenge drain. So you can keep full open and then you can reduce it so that you can when you open the fully, then it will have a blow through process because scavenge pressure is higher than your scavenge drain tank. And also when it is in a stop condition, that time you blow through the line of the scavenge drain line, individual drain line, so that you ensure that there is no blockage. Ephraim, is it clear to you or you ask something else?
Chief, can you explain about the surging?
So what do? You can shut it off. Surging of the turbocharger.
Yes. Yes.
That is there in your syllabus. I'll come to that. So blow through you can do like you shut it off and open immediately. So what will happen? The pressure will accumulate and then it will clear the line. Surging is there. I'll come to that. So the increase in exhaust temperature of the affected cylinder, that is one of the indication symptom. Turbocharger will surge. That is also another indication. The smoke from the turbocharger air inlet filter, because when there is a surging because of the scavenge fan, what will happen? There will be a reverse flow of air gases from the delivery side to the suction side of the turbocharger. So what will come out? That the smoke will come out because there is a, otherwise in other condition surging, what will happen? The air will come out. But in this case, since there is a fire in the scavenge space, so because of the reverse flow, smoke will come out from the inlet. That is the air inlet filter, and the surging will occur. And the monitoring device, what you have for the scavenge fire, the alarm and slowdown, that is the temperature alarm, and the slowdown at abnormal temperature increase when, and the scavenge airbox noticeably will be hotter. And usually there are two sensors, one is 60 degree and one is 200 degree centigrade. So once you reaches to the 60 degree centigrade, then you will get an alarm. and it can give you the slowdown, and 200 degree once it reaches, definitely it will have the slowdown of the engine. So it is incorporated alarm as well as the slowdown, and in case of abnormal increase of temperature. The heat sensitive paint and tape color, it is placed in the unit under piston space door. Why it is heat sensitive paint? It is, suppose it has reached to 200 degrees centigrade, and then above 200 degrees centigrade, it means already alarm is there. After that, you will be knowing what is the condition. So from where it has come. So there are tape or the paint which changes the, as per the heat, it changes the color. By seeing that, you know from which area it has the fire has come, and the tape color will change at high temperature. And the individual unit piston cooling return line temperature will also increase, because the under piston area is heated up, so the piston temperature will increase, and your piston cooling return line temperature also will increase. Fire, if it is violent, the smoky exhaust you will see from the funnel, as well as you will see the decrease in engine revolution. Why? Because now the scavenge space, instead of air, you are having the exhaust, and that is going for the scavenging. What will happen to the power? Your fuel will not be burned completely. What will happen to the power of the engine? When it is violent, the fire is large fire, the engine RPM will drop. And then violent blow by will cause the smoke, spark, even flame to blow out. And in the scavenge drain cock, if you open, you will see that there will be smoke, spark, and the flame is coming out. That's why when you open that the drain cock, you should be very clear, means very very careful, so that you should not be exposing to that. Then the fire, you will be injured. So you should keep yourself in such a way so that you open the cock and see the condition inside, by which you can see that what is the means the extent of fire, and then you shut it off. And the corresponding scavenge drain cock is open, so that the keep clear of the line of injection, because the spark can smoke with high temperature, even the flame can come out. So after that, you shut it off. You know that from which unit it is coming. What action in case of a scavenge fire? So there is a possible risk of explosion of the crankcase also, because the heat can go to the crankcase, because it is on top of the diaphragm. In under the diaphragm, you have the crankcase. So the crankcase relief valve is a violent flame can suddenly emit. That's why do not stand near the crankcase relief door also. The scavenge relief door also you don't stand, as well as the crankcase relief door. Inform the bridge and sound the engineer's alarm, and then start additional generator and stop the shaft generator. Suppose you have the shaft generator, you'll have to stop it, because you'll have to reduce the engine. Freshwater generator to be stopped, because at low RPM you won't be able to run the freshwater generator. Do not stand near the scavenge space relief valve, because violent flame and the suddenly it can emit and injure you. Reduce the speed to slow. Do not stop the engine. For scavenge fire, reduce the speed to flow, and the so if it is the slowdown is incorporated, then it will automatically slow down. But if not, then you'll have to do it manually. And cut off the fuel supply, that affected unit, you supply of the fuel you cut off. Then the fire extinguish itself, which means if you cut off the fire, then what will happen? The just wait. Yeah. Sorry for the interruption because there was a call from one person. So this reduce the speed and cut off the fuel. Once you cut off the fuel, what will happen? That unit, the heat energy will not be there, and it should get extinguished when you do this condition. It should get extinguished itself. What will happen now? There is no heat energy and there is no fuel, and slowly all the deposits will get burnt out, and then it will stop the scavenge fire if it is localized. And cylinder lubricator lubrication has to be increased to avoid the seizure of the piston and the line, but you should not increase too much, then also then it will add to the fuel. So it is the professional judgment at chief engineer level. The chief engineer can take that judgment that how much it will be increased. And coolant flow through the jacket and the piston to be maintained uh, to the affected unit. The coolant flow should not be stopped because the heat has to be taken out from the unit. And the scavenge space drains are to be shut so that no spark in the engine room, and fire spread to the other unit. Suppose, then what will you do? Then you stop the engine. So bridge, you ask for stopping the engine. So after bridge, the bridge will give permission. What the bridge will see that if the ship is safe to stop or not. If not, then a bridge will not give permission at that moment. Bridge will take the vessel to a safe place, and then they will ask you to stop. So because of that permission, once you get, then you stop the engine. First thing what you do, put off the auxiliary blower. It means you are cutting off the air supply, and then stop the lubricating oil supply, because it can lead to your crankcase explosion. Cover the turbocharger air suction filter so that by the draft also air should not go to the scavenge space. Then put the scavenge air box fire extinguisher equipment into function. Usually it is done by the steam or the CO2. So release smothering gas, steam or CO2 for the extinguishing. And steam smothering, when you do, you keep the drain open so that the water should not get accumulated because of the to avoid the hydrogen fire. So that from the line, so that the water gets accumulated, it means water will drained out, because steam can become water and it should get drained out, so that to avoid the hydrogen fire. Once there is a hydrogen fire, what will happen? The hydrogen fire will produce very high heat energy, then it will add to the heat energy, and then there will be fire will not be extinguished. There will be metal fire. And using CO2, the diffuser head is essential, because when it injected, because CO2 is stored into the liquid form, and when it is injected, it should be in the gaseous form, so that the gas and not the liquid is been injected. That's the reason the diffuser head. In the diffuser head, remaining liquid is been liquid. When it is discharged, actually it is from the bottom, and what you have the from bottom is the liquid, and then it changes the state to gaseous stage because of the diffuser. So diffuser head is essential, and when you release the CO2, that time drain should be shut. Do not open the scavenge air box or the crankcase uh, when there is a fire has cooled down less than 100 degrees centigrade. Once it cooled down less than 100 degrees centigrade, then you can open the scavenge air box and the crankcase. And always keep clear of the possible fresh sprout of flame can come out. So when you open, be careful. Remove any deposits of the sludge from all the scavenge air box. You'll have to clean absolutely, and clean the respective piston rod and the cylinder liner, and inspect their surface condition and the alignment, whether it is distorted, in order to coat with the lube oil. It means that a piston rod has to be, trueness has to be checked, so that you know there is no bend has taken place. Cylinder liner surface will have to check, so the surface condition is okay, alignment is checked, and whether any distortion is there or not. And if in order coat with the lube oil, you put the lube oil coating on the surface, so that when you turn the engine, it will lubricate, as well as the friction will be reduced. Then continue checking the concentrate piston crown and the skirt for damage, and engine being turned and cooling water is been on, and you'll have to turn it. That's why you put the lube oil on the surface piston rod. And then inspect the stuffing box, because stuffing box is chances of getting damage is high. Why? Because the segments are very soft material compared to the other material, so that can have bent or cracked. So stuffing box casing and the segments has to be checked for possible crack or bend, and the piston had the caused the fire, that particular piston has to be overhauled, and you check the piston condition and the piston ring condition. That particular unit piston has to be completely overhauled. Full overhauling has to be done. And that suppose you cannot overhaul that piston, remove that piston, then what will happen? You cut out that unit. You'll have to cut out that unit, because otherwise again the scavenge fire will take place. So once you cut out, but your cylinder lube oil should be on, so that it does not, the piston and the liner does not get seized. And then in that case, in first opportunity, you dismantle the piston and you do the overhauling of that unit. Scavenge air box wall also can be, because it has a temperature had increased, so it had heated. The stay bolts has to be retightened on the first opportunity. And before retightening, all engine parts should be normal operating temperature. Then only tie bolt should be retightened. Now, one of you actually asked some question that 51 cylinder is been discharged. Is it sufficient for the engine room CO2 flooding? Who has asked this question?
It's me, sir.
Yeah, Abebe, you asked this question that it is not that 51 or the 61. There is a calculation of how much CO2 to be released to extinguish the fire. As per the SOLAS regulation, there is a calculation. One of the lecture, I'll show you that calculation. You will understand. It is the calculation of total volume of the CO2 to be discharged, so that fire can be extinguished in the engine room. And that calculation based on, it is a simple calculation. I'll explain to you in that lecture, you will understand. Understood? It is the volume actually. And each cylinder has got a volume. So divided by that, that becomes the number of cylinders. So now the fire extinguishing system. So we have the steam or the CO2. In case of steam, then the drain has to be in open condition, and CO2 drain has to be in closed condition. Usually there are two CO2 bottles in the engine room. It is in the engine room close to the scavenge space. It is kept, and then you can open manually that valve of that unit, means all the unit has got individual valve that has to be unit is affected, has to be open. So this has got the individual unit, valve has to be opened first, and then the bottle valve. And as I was telling you that this is the pipe. It is deep into the liquid. This is the liquid. So the liquid is coming out. So diffuser head, it ensured that when it is injected, it is the gaseous form, not in liquid form. And also like this valve has to be opened first, because once you open, this pressure is high pressure. So what will happen? You won't be able to open this valve. That's the reason one of the reasons that master valve should be opened first and the uh, bottle valve should be after, because master valve you won't be able to open otherwise. And this is for the so that the liquid does not get frozen. If it is from the top, then what will happen? This the gaseous form, suppose it's discharge from the surface of the carbon dioxide, what will happen? It will get evaporated. Heat energy, it will be for evaporation, the heat needs heat energy. From where it will come? It will come from the liquid, and liquid temperature will reduce, it will get frozen. So the system will not work. So this is the two system you have, and this drain will be in open condition to the bilges. Now the crankcase explosion. So the under normal condition, what happen? What is the atmosphere in the crankcase? So engine is running. It contains a large amount of relatively large oil droplets, and it is around 200 micron in the hot air or the warm air. And because of the droplets small surface area, because large droplet will have the surface area will be the small, so volume ratio, it will not possible to ignite by the heat surface is available there, because heat surface is the heat source is very low because of the warm air, and this droplet size, the surface area is too large, too small, so that it will not be sufficient to ignite. But what happened? Suppose overheating has happened in the crankcase for an example, due to the failure of the bearing. Then what will happen? The hot spot will be created. Once the hot spot is created, then what will happen? The temperature will reach to around 400 degrees centigrade, and then there are two different temperature range at which it can become uncombustible mixture, and 270 to 300 degree centigrade and over 400 degree centigrade. And what will happen? This lubricating oil, when it falls onto the surface, that hot surface, then what will happen? It will get vaporized. Once it vaporizes, then what will happen? It becomes lighter. It will travel from that space. So it will move to a cooler area. Once it goes to the cooler area, then what happens? It gets condensed, this droplet, and it mixed with the air. And then it become a white, highly dense white mixed. White milky mist it will form, and that mist, the size of the globule will be 6 to 10 micron. Now same global, that is 200 micron, has become separated into 6 to 10 microns, many globals. Then what will happen? That surface area will increase and the heat requirement for ignition will be less. Then what will happen? This will not ignite still. Then it will create a high surface area to the volume ratio because of the micron is reduced. And this is the temperature and the weight percentage of oil. Vertical axis is the temperature. If you see, this is the 270 to 300. This is one zone, that is the combustible zone. Another combustible zone is this above 400 degrees centigrade. So what will happen now? The smaller in size, it will come to this area. And once it comes to this area, this global, the hot spot, it will, because it will be on natural circulation, because the lighter globals will move to the upper direction, and then it will displace the colder will come, and it will become colder, and it will come back to the hot spot again. And once it comes back to the hot spot, what will happen? The original vaporization now is possible, and the oil mist will be formed, and at a temperature around 350 degrees centigrade. We have seen it is the ignition range it will be, and then it will get ignited under around below 500 degrees centigrade. It will get ignited, and it will be getting ignited at lower temperature because of the global size has reduced. The lower range, it will be in the lower range. And white milky mist increase in size and density until the lower flammable limit is reached, that is the 50 milligrams per liter is generally found in real situation. Then what will happen? It will result into the explosion. And the explosion will be relatively, it can be mild, and explosion speed can be few centimeter. Explosion also will vary. It can be mild, it can be huge explosion, and explosion speed also can vary. It can be few centimeter per seconds, and little heat and the pressure rise to the severe. And there can be a shock waves, because your crankcase, there are partitions. So there, this pressure will try to release. So there will be shock waves. And that sometime it will stop, sometime it will increase. Whenever there is a passage, the pressure will increase. Whenever you have the movement of the high pressure is stopped, and then it will become severe, and the shock waves will detonate, means it will be around detonation velocity. It means when you high explosion you have, then the flame moves very fast. You can have that velocity up to even 3 kilometers per second, and pressure it can reach to the 30 bar. Then there can be a primary and the secondary explosion. If the primary explosion happen, then what will happen? The pressure will increase, and this excess pressure has to release, because otherwise your this crankcase will get damaged, which we don't want. That's why there is a relief door. Relief door will open, and if the relief door does not close properly, then what will happen? When this relief door opens, after that the pressure will release, and then it will go below the atmospheric pressure at one point. Suppose it does not close, then what will happen? The atmospheric pressure is higher, engine room pressure is higher than the inside pressure. The large quantity of air will enter into the crankcase, and then there will be a secondary explosion. And if you see the pressure, secondary explosion, the pressure is much more higher than the primary explosion. So the secondary explosion will be more dangerous, and then crankcase can be ruptured also. So the crankcase explosion, that initial explosion when pressure drops, and then uh, if the safety, it means not safely dealt with, that is the crankcase door does not close properly, then this thing will happen. and air will drawn into the crankcase, and there will be a secondary explosion which is much more higher than the primary explosion. And the limit factors of the explosion is the supply of the fuel and supply of the oxygen and the air. So the slide vacuum is created by the primary explosion. The supply of the fuel is created by the passage of the shock waves, and it will shatter the large. When there is a shock wave, then what will happen? The large globals droplets will you will part divide into smaller size, and then that will become a combustible mixture. And then that's why when there is a explosion, there is a shock wave, and then the fuel, it will add fuel, because combustible mixture will be increased. And if you have the uh, relief valve does not sit properly, then the large quantity of air will enter. So you have the air, you have the fuel, and then you have the heat already, so there will be a secondary explosion. So now the venting of the explosion through the relief valve, so it will drop the pressure in the crankcase and below the atmospheric pressure. And why it will be below the atmospheric pressure in the crankcase? So okay, just think about this answer, and we'll take a coffee break for 20 minutes. And after the 20 coffee break, we'll start at 3:20. Then sorry, then now it is the lunch break. Okay, then you can answer to this question. Not the coffee break, it is the lunch break. So tell me why the pressure will drop inside the crankcase below the atmospheric pressure, below your engine room pressure. It should stop at engine room pressure, isn't it? Once become equal, but it will not happen. Why? Anybody wants to answer to this? Or let us, after the last class is the EKM, that time you can answer. Okay, let us take a lunch break for 1.5 hours, and we'll start at 1:30 again. So good afternoon, everybody. This electricity, what I'll do, I'll do tomorrow morning instead of doing now. So what I'll do, this EKM I'll complete. I mean, these two classes will be EKM. Uh, so tomorrow morning EKM, there are two classes. I'll convert one of the class to electricity. Let us start, continue with that EKM, that is the abnormal condition of the engine. So as we have seen that if there is a primary explosion, in if there is a, if the, and if the relief valve does not sit properly after opening, releasing the pressure, and there can be a secondary explosion because of the large air will enter into the crankcase, because the crankcase pressure will fall once the primary explosion happen and the door opens. It will fall below the atmospheric pressure, and there will be wave uh, inside the crankcase, and due to the wave the velocity will be high, and the oil mist, that is the droplets, will reduce to small droplets, and there will be a secondary explosion. And I asked you one question before lunch, that how the crankcase pressure will go to the below the uh, atmospheric pressure. Who is going to answer to that question? Just think and answer. Yeah, Mesfin, tell me.
Yes, Chief. Whenever there is explosion, then whatever amount we have in the crankcase, that's already burned. So it will take suction from the outside air, because the outside air will be more than what is available in the scavenge.
But your scavenge pressure was high, no? That's why you release the pressure. It is the question of gas. It is not the question of air, oxygen or something. So total, it is the pressure difference, it will flow. Isn't it, Meswin?
Yes, Chief.
Uh, just think something else. And Abebe, what is the answer from you?
Due to rotation of the crank shaft or crank wave, it creates vacuum.
But due to the rotation of the crank, if it creates vacuum, then normal condition also it will create vacuum, isn't it?
Yeah,
But normal condition, it is not vacuum. It is normal pressure.
But Chief,
Yeah,
whenever there is explosion,
yeah,
the pressure develops because of the burning gas. Now the
yeah,
burning gas already relieved. Then
yeah.
there is no space in the crankcase, between the crankcase space and the oil. We'll only be having only the oil. So that time it will make a vacuum in the remaining space.
Okay, let Medga once raised hand. Tell me, Medga.
Chief, I would say the pressure was high during the explosion, and it starts to drop. So it drops a little bit to the pressure below atmospheric pressure, and temperature was high also during the explosion. After explosion, temperature also drops, results in dropping pressure below the atmosphere.
Let us see this way. This is the wall, and we have the crankcase. Now what had happened, there is P1 here, which is, and this is P2. Now P1 is more than P2. Just think about pressure, nothing else. Then what will happen, when this wall will lift because of the differential pressure, this will come out. The pressure will release through this. It means the mass of gases will come out. Whatever is the gases, it is the pressure difference will make the flow. So now what will happen, when it is open, like we have seen in the Labrinets cell, I have mentioned that the velocity also has to be reduced. Otherwise, what will happen, with that velocity will move out. Now just think this gap is like a nozzle. So what will happen, when the pressure is released through this gap, then the velocity will increase. With that velocity, what will happen, the more mass will come out in spite of the P1. At one point, P1 is equal to P2. Because pressure is releasing, P1 will keep on dropping, one point it will be P1 is equal to P2. But still, because of the velocity, it will come out. The more mass will come out after even the equilibrium position. By the time it closes, more mass will come out from the crankcase. So what will happen? The crankcase pressure will drop, which you even will be able to control that pressure drop, because it will go beyond the. For example, just think about the this thing, naturally aspirated engine. How it happens? Atmospheric pressure, we attained a velocity so that with the atmospheric pressure also, even if it is equal pressure, atmospheric pressure, with that velocity more air enter into the cylinder. Similarly, the more gases will come out from the crankcase. So the crankcase pressure will drop. Understood? Because of this kinetic energy with the velocity. So the more mass of gases will come to the engine room, and the pressure will drop below the atmospheric pressure. That is the below the engine room pressure. That is the atmospheric pressure for the engine room. Yeah, Meswin, tell me.
Yes, Chief. In this case, we can make the relief valve non-return valve, only allowing one way the explosion to come out and nothing will go inside. So this will prevent maybe the secondary explosion.
Relief valve is non-return valve only. But if the maintenance is poor, relief valve does not sit properly, then only the atmospheric air, that is the engine room air, will enter into the crankcase. That's why one of the condition that relief valve should sit smartly, means immediately it should sit. You use the light spring so that inertia effect is less. But it is a non-return valve, but it will not sit properly because of the poor maintenance. That is the reason. It is there in your syllabus, the relief valve. I'll come to that. You will see it is a non-return valve only. The one I have drawn also, it is a non-return valve, isn't it? It will open in one direction only. But it can be, suppose it does not close properly because it is seat is damaged, or there is O-ring on the seat that is damaged, or it is stuck because it is not, maintenance is poor, then it can happen. Now the primary explanation, we have seen that what will happen, there will be pressure wave, and because of that large amount of oil mist into the engine room, it will come. Now we don't want any flame to come out to the engine room because there will be an engine room fire. So what is there, there is a flame arrestor in the relief valve which prevent the ignition of the oil mist by the flame front. So when it's passing through the flame arrestor, what will happen? The flame will be arrested and the hot gases will come out. And that is and another thing, there's mist which can move upward direction because those are lighter, because it is heated. So it can go to the towards the turbocharger where it may be ignited because unlocked hot exhaust manifold. That is another problem. And if the flame flame front is, then the mist is sucked upward to the turbocharger, then there will be a turbocharger explosion because that will enter into the turbocharger compressor side. And the ignition of the oil mist causes the severe damage to the plant and the personnel also in the engine room. The largest risk of ignition of the oil mist is the flame arrestor on the relief valve. If it does not function properly, then what will happen? The engine room fire it will lead to. And the flame front, that's why it has to be maintained properly so that it does not happen. And flame front, from the explosion in this, it will ignite the engine room also. Now this is suppose a flame arrestor, it does not work, you can see what can happen. So that will be a engine room fire, and the flame will go to the turbocharger inlet side, and because engine is still running, you will be having the uh, turbocharger explosion also. It had happened. There are ships that had happened. So what action will be taken? The potential now, do not stand near the crankcase door or relief valves, nor in the corridor near to the door, because when it lifts, it will release the gases, and in the corridor it will travel. So engine room casing, in the event of near the engine room casing also don't stand, because what will happen, these gases with high pressure will try to escape to the atmosphere. It will move through the corridor, and then it will go to the casing and come out to the atmosphere. So there are alarms. What are the alarms? Oil mist alarm 1, high lubile temperature alarm will get, no piston cooling, oil flow, suppose you get alarm, scavenge firebox you got alarm, high bearing temperature. B, C, D, E are the indication of the, it is an warning, and means it is the indication, pre-warning that there can be a crankcase explosion. Like we have seen scavenge box fire, there can be subsequently there can be a crankcase explosion. That's why you don't stand near the door. So near the crankcase relief door. The first one, it means it has happened. Actually, it has happened means the explosion has not happened, but the atmosphere has reached to the, it is leading to the crankcase explosion. So alarm B, C, and D are the pre-warning. So once you receive that, be careful. You must deal with that. There can be a crankcase explosion. It can lead to a crankcase explosion. What will you do when the oil mist detector, then the possible increase of oil mist level in the crankcase because of those alarm B, C, D, and E, then reduce the speed. Once you reduce the speed, what you are doing actually, your heat generation will be reduced, because the heat will generation hotspot temperature will reduce. And suppose it is a CPP, controllable pitch propeller, then the CPP has to be reduced, pitch has to be reduced, and if not, it is automatically reduced once you get the oil mist detector alarm. Then bridge has to be informed for permission to stop, and then once bridge gives you permission, then engine stop order is received. Stop the engine. What you do after? Close the fuel oil supply. You close the fuel oil supply, switch off the auxiliary blower, switch off the engine room ventilation fan, open the skylight and the stored hatches through which you remove the store and the put the store inside the spare parts, that hatches. Leave the engine room. Don't do anything. Leave the engine room and lock the casing door and keep away from them, so that if there is any explosion, nobody will get injured. Then prepare the firefighting equipment. Just prepare. Do not open the crankcase at least 20 minutes, 20 to 30 minutes. You stay outside. Do not open the crankcase door after stopping the engine. Because once you stop the engine, what will happen? The temperature will reduce, and 20 minutes you wait. Because if you open the crankcase door, what will happen? There is a hot spot still, and the air will enter, and there can be an explosion. And oil mist detector, again you check the condition. you stop, reset the oil mist detector and see if the condition alarm persists, and avoid allowing the excess oxygen to enter when opening up, or in the crank, means the crankcase. When you open, what you open, actually open the breather pipe. Don't open, you see in the breather pipe where that is a, from the tank it is going upward direction to the oil mist uh, chamber in the funnel. You will see there is a small piece of pipe, you can remove that. So open that pipe, breather pipe of the crankcase, so that the air will not enter much into the crankcase. And keep clear yourself for the flame, because flame can come out from there. So to check the crankcase atmosphere, open that. If there is a fire, you can see that there is a fire, if some flame or the spark will come out. Oil mist detector reading, if it is clear, then on no indication of the residual oil mist, then stop lube oil circulating pump and safely isolate. It means the lube oil circulating pump will keep on running because it removes the residual heat, and safely isolate the engine against starting, so that engine cannot be started. Starting system you isolate, and then remove the crankcase door and stop the circulating pump and take off the crankcase door only from the one side, and engage the turning gear, keep turning the engine, so that if there will not be any seizure of the engine. Then you'll have to locate the hotspot with the powerful lamp, uh, and feel over by hand or the thermofill. It means you have the infrared thermometer. With that you feel it, where is the hotspot, and all the sliding surfaces has to be checked, because hotspot will be from there. And bearing, thrust bearing, piston rod, a stuffing box, crossset, telescopic pipe, chain gear, vibration damper, then the moment compensator, because there is a rubbing action. Then if any bearing metal, suppose inside the uh, crankcase, you find that is that bearing is there was a hot spot there, so that squeezed out material and discoloration caused by the heat, the paint of blister, if you see, burnt oil oxides, steel color changes if the at high temperature it gets oxide. So you know there is a hot spot in that place. So keep possible bearing metal found, whatever bearing metal you will be found in the crankcase, that squeezed one, that you need to keep it for sending for analysis. Superintendent will ask to send it for analysis, so that laboratory analysis will tell what is the actual reason. And hotspot by preferably making a permanent repair. When you have found that hotspot, you will have to make a permanent repair and ensure that the respective sliding surfaces in good condition. And then only you restart the engine. Take special care to ensure that the circulating lube oil pump supply is in order. Suppose the supply is there was a blockage in the lube oil supply, then also hotspot will be created. So you'll have to eliminate the hotspot. After that you can start. Then start the circulating of the lube oil pump, and then turn the engine by means of turning gear. You turn the engine, and oil flow from the bearing, all bearing, spray pipes, that is the chain drive or the gear drive, those are sprays, all thrust bearing, and all this thing has to be checked that flow of the oil is correct or not. Crankcase, chain case, thrust bearing, and then check for possible leakage from the piston or piston rod. If there is any leakage, then what will happen? Piston rod will get overheated, and that can cause also a hot spot, because the oil is spraying onto the piston rod also, because it is in mist form, and then that oil can get evaporated and same thing can happen. So do not start the engine without determining the cause of the oil mist and carry out the remedial work to remove the cause of the hotspot. And cause of the hotspot, once you have removed, then start the engine and crankcase doors completely secured and run a few minutes, 2-3 minutes you run. After that, stop the engine. Then again isolate the starting system. Remove the appropriate crankcase door where there was a hotspot, and then check the original problem area if it still exists or not. Temperature you can check. Once you check the temperature, you know the other unit temperature and this unit temperature is same or not. You can compare. And then the similar check after that, what will happen, you will run for 30 minutes, and then similar checks will be carried out. Each time you'll have to stop and check thoroughly, and 1 hour gradually it will increase, 1 hour then, and then is slowly then you gradually increase to full load once you ensure that there is no hot spot is existing anymore, and carefully monitoring the mist detector, lube oil and the bearing temperature. There is a possibility that oil mist is due to the atomization of the circulating oil. It can cause the air, suppose there is a leakage in the pipe. There are pipe connection, there is a leakage, crack or the pipe flange is leaking. Then what will happen? It will come out its atomized form, and suppose it is splashing onto the crosshead or the piston rod. Then what will happen? Those are the hot, means the temperature is high, and then it will get evaporated because it is in atomized form. Stuffing box leakage, not airtight, then from top it can enter into the, it can cause to the crankcase explosion also, because this once the stuffing box is leaking, then what will happen, that the from the stuffing box the air will, high pressure will come down, and that can actually mixed with the piston rod is having the oil, and then the stuffing box also has got the oil, that can have the atomization can take place, and that will go to a temperature where it can get evaporated, because those will be very small droplets. Blow by from the cracked piston crown. Suppose the piston crown is cracked, then what will happen? The engine room, means the crankcase, what will happen? And there will be a blow by from the, because the pressure and the temperature is high on the top of the piston crown, that will come to the, through the piston rod, it will come to the crankcase, and then that will be direct contact with the cooling water outlet pipe, and then there can be there can be evaporation and explosion. Oil mist also develop resulting the heat of the scavenge fire. If scavenge fire will take place, then what will happen? The heat will transmit it downward direction through the piston rod, stuffing box and the diaphragm. So the hot air jet or the flame can pass through the stuffing box into the crankcase, and then you can have the crankcase explosion. Hotspots in medium speed engine due to the piston season, or the could cause, then for an example, the leaking distillate fuel injector, and then it will go directly to the crankcase because there is no scavenge under piston area. So the piston ring and the liner were down high, and your leakage, there can be a blow pass, and the badly leaking the fuel injector, then it will go to the crankcase, and there can be a crankcase explosion, because your lube oil will be contaminated with the fuel oil, and then that can, and flush point reduces drastically because of the lube oil, the fuel oil, and then it can get ignited. Now, one of the protection, we have the oil mist detector. What is oil mist detector and how it works? There are two types you have. One is comparator type, one is the label type. So the comparator type, how it works? The now any question on the crankcase explosion? Yeah, Ephraim, tell me.
Sir, during the crankcase explosion, we leave the, I mean, we keep the lube oil pump running, right?
Yeah, yeah.
So does that mean it can aid the fire? I mean,
No, because once you stop the lube oil pump, what will happen? It will remove the residual heat, and once you removes the residual heat, means the temperature will move down. It will not be increased because you stop the engine. There is no friction, and lube oil you are starting keep on running to remove the residual heat, because heat will the temperature will drop because of the stopping of the engine, and then lube oil will take out the residual heat, so it will keep on reducing, because temperature is one of the factor for the evaporation. So that's why it has to be keep on running. Understood, Ephraim?
yes, sir, it's clear.
And anybody, I think somebody else, yeah, Mesfin, tell me.
Yes, Chief. My question is not from this crankcase explosion, but from the scavenge side.
Yeah, tell me.
You have said we have to keep it clean, and we make some blowing. So can you explain that?
That is blow down of the your uh, drain line, isn't it? That's what you are talking about. So
Yes.
what do you do? That gets choked many times, isn't it? That's why periodically you do clean that in the port. And what you can do in this thing, sometime you just put it off, means close it, and then suddenly open it. What will happen if you close it, and like many times we do to clear something, so we shut it off and then you open it suddenly, then what will happen? Because of the pressure difference, suddenly some mass will come out. So that is the blowdown of the scavenge drain line. You'll have to keep it open always, and you open, actually you keep it open, but sometime what you do, you shut it off, and then your scavenge pressure is higher than the tank pressure, because there will be a tank has got a vent and the pressure gets released. So uh, then you suddenly open. Once you suddenly open, then what will happen? The pressure difference will be high, and with that with that velocity, kinetic energy, the it will get cleared. And that's what it is talking about. Understood, Mesfin?
Yes, Chief.
Now the oil image detector, that there are two types, as I told you. One is comparator type. So the this each crank chamber is compared in turns with the combined mist or the remaining chamber. So okay, somebody raised hand. Mesfin, you raised hand or somebody else? Khalid. Yeah, Khalid.
Yes, Chief.
Yeah, Khalid, tell me.
I have some question on scavenge fire.
Yeah, tell me.
So what I faced on board, one of the unit is always the scavenge fire temperature get high.
Yeah.
So the chief engineer always write something on board on whiteboard, some arrangements. From that arrangement, what I see is we adjust air cooler.
Say again. What adjustment you made? Khalid.
For instance, the chief write on whiteboard, and
Yeah.
they say uh, sometimes we reduce the fuel rack position. We reduce for that unit.
Yeah.
The other jacket also scavenge drain box at every watch we use to drain. And the other thing is we adjust the air cooler.
What you adjust in the air cooler?
Air cooler water, the cooling system.
So
Air
now,
cooler.
yeah, then what happened? Then the temperature reduces?
Yeah, temperature reduced when that design is old model. I don't know whether all the engines have that system. I don't know. It's built in 1993, 28 years back. So we adjust the one is the three-way valve lever, so the temperature will reduce the scavenge temperature for that unit. So
So
how
it,
we
yeah. What
that
says? What is your question?
my question is how this
Help.
adjusting air cooler will reduce the temperature.
No, you see, what he did the fuel rack reduced. It means the that in unit is producing less power because he reduced the fuel rack. Other unit
Yes,
is taking the more load to maintain the same RPM. Another thing what he did that the cooling water flow he has increased. So definitely the heat energy from the cylinder has been removed. Another thing what he did is the air cooler temperature he reduced by doing so, or what he did actually, what the chief engineer on board that ship did.
that air cooler there is a three-way valve, big valve, this with the hand lever. So
Yeah,
that valve we adjust, but provided that the pressure of the seawater could not pass 1.5 bar. And so how that air cooler for the water, seawater, cooling seawater.
yeah. So what he did actually, cooling water, seawater he controlled, and the temperature he wanted to reduce the scavenge temperature. Scavenge temperature, if you reduce, what will happen? That three-way valve, what we are talking about, it is the temperature controller basically. Manually you adjust because what happened? The engine runs at constant speed, so you can adjust manually that. That with the lever you said, isn't it? So it was manual operation. He adjusted that. So he what he did, he increased the flow of the water through the cooler. So to reduce the scavenge temperature. Now, if you reduce the scavenge temperature, what will happen? Your exhaust temperature will reduce because this scavenge temperature goes inside the cylinder and inside the scavenge space, and the temperature will reduce in the scavenge space also because this air goes to that lower temperature. Now it is going to the scavenge space, so definitely the temperature also will drop. And also he what he did actually, he reduced the fuel, so the power also is now the force and heat generate less fuel it is burning, so the heat generate exhaust temperature of that unit uh, uh, unit may be high, but tell me the exhaust temperature was high or not, or same to with the other unit?
Exhaust temperature also reduced.
Yeah, because of the fuel he has reduced, and the air temperature has reduced. But this is not a there is something wrong with that unit. So should have checked that, because
Yes,
by reduce yeah by reducing the rack, that is the makeshift arrangement. It is not the permanent solution, because you're just reducing the rack like generator may sometime sometime it is done on generator because there is no time, so rack is adjusted to reduce, but then you do the correction that what is the actual problem, and then you repair it. So in this case also, just because that to reduce the temperature, definitely he did the right thing. It is done by the all the chief engineer will do in suppose he cannot stop the engine and check that. So definitely he has to run the engine. So he did it that. Like if there is a scavenge fire, we cut off the fuel, isn't it? Why you cut off the fuel? Because there is no heat, means the heat energy added to that unit. So he reduced it instead of that because there was no scavenge fire, but the scavenge temperature has increased. So he wanted to reduce that. But there are certain things I don't know whether you have noticed or not. Has the chief engineer checked the compression pressure and the peak pressure of that particular unit?
Actually, Chief, it's very difficult engine. Now it's already scrapped. That very complicated problems are there. So in order to, until we reach at port for it for that purpose, we only reduce the fuel rack.
That
After
ship
that,
was,
we already overhauled the unit
yeah.
only for that specific time. But air cooler, how it reduce, it's not clear for me now. I understood.
Yeah, that is the air cooler is gives the cooling of the piston, and when the cylinder air temperature is less, then the exhaust temperature also will be less. It is uh, every 1 degree change of temperature of the air cooler, exhaust temperature reduces. Suppose 1 degree reduce the temperature of the air cooler, the exhaust temperature reduces 1.5. If you can reduce 5 degree, exhaust temperature will reduce by 7.5 degrees centigrade. Understood? That is the relation for seawater. So now this comparator type. So what it does, it takes sample from uh, each unit. It means each unit is compared with the other all unit together. So that is the comparator type. So each crank chamber is compared in turns with the combined mist from the remaining chambers. And mostly it is used in crosshead type two-stroke engine. And low background of the oil mist, and they are actually because of the slow speed engine, so the background of the oil mist is less. And this is another thing is the crankcase is divided for the four-stroke two-stroke engine, whereas four-stroke engine is not divided. There is no A-frame. So what will happen in two-stroke engine, it is subdivided. That is the reason in the slow speed engine, what it does, each crank throw, you take the sample and it compares with the remaining of the unit. So that comparatively, which unit, if you have the average value and the individual unit, what is the difference, it has been checked. So in this case, there is a reference tube and a measuring tube. And through the reference, through the measuring tube, only that particular unit, suppose this is 1, 2, 3, 4, 5. This is not the unit, the 5 will be this one. This is 5, and this is 6, this is 7. And this is 6, 7, 8 unit you have. So number 1 unit is in this condition, it's going through the measuring tube, and remaining all unit is going to the reference tube. What does it mean? It is comparing the one unit with the remaining unit. And the system is like this. There is a photocell here. There is a photocell here. And then there is a mirror here at 45 degree. There is a mirror here at 45 degree. And this is the lamp. And this ray is reflected and passing through the measuring tube and the reference tube. And if the concentration is same, then what will happen? The photocell will get the illuminated, same illumination will be there. Now then it is balanced. Now what will happen? If there is a difference, then what will happen, depending on how much concentration is different, difference is there, because what will happen, this photocell, when there is a mist is going through this, then what will happen, there will be light energy will reduce, which is going to the photocell. Illumination will reduce because there will be obstruction, and because of that, there will be a difference in whatever concentration difference is average concentration with that particular unit concentration. Then there will be a difference of there will be this circuit will be imbalanced, and because of that, there will be some current, voltage will be created and current will flow, and that will be measured, that how much is the difference in concentration of the beast in that particular unit compared to the other unit, and that will give you a value, and when it reaches to a preset value, then it will trigger you an alarm, and it can be incorporated in the slowdown. The engine can be slowed down, but it is not then necessary that all the ship has got slowed down. You might not have slowed down, but there is ships which is incorporated into slowdown. So is it, and there is a fan which is drawing the sample continuously.
Can you repeat this one, sir?
Yeah, there is a rotary valve. This rotary valve means this is the valve which is rotating. Suppose it is rotating in clockwise direction. Now all this 1, 2, 3, 4, 5, 6, 7, 8 unit, it is connected, it coming from, there are pipes which is connected to the each crank space for each unit. And in this rotary valve, now it's connecting to the number 1 unit. It is taking sample from the number 1 unit and it is passing through the measuring tube. And remaining unit also is been, sample is taken, that is together is going to the reference tube. Now what will happen, this fan is drawing this sample, and this also, this is the reference tube, all the unit gas sample is going through this. And once it is passing through this, what will happen, this illumination of the light will reduce because there will be some absorption of the light. And here also there will be some absorption of the light. Suppose the concentration of all unit is same, then what will happen? This concentration and this concentration is same. What will happen to the illumination of the on the photocell? It will be same. So circuit will be balanced. There will not be any output. But now suppose this level, this concentration is lower than this particular unit, the concentration is high, then what will happen? This will have the less illumination than this. So there will be a current flowing, and that current will be proportional to the difference in concentration. So accordingly, it will show the level of concentration difference, and then at predetermined set value, once it reaches to that, then the oil mist detector will give you an alarm. So this is the way it is. It means what will happen next time, each sequentially it will check. This rotary valve will come to this point. Because it is rotating, it will stop here, it will take the sample, it will measure, after that it will shift to this. Once it reaches there, then what will happen? Number 2 sample will pass through the measuring cell, and 1, 3, 4, 5, 6, 7, 8 will pass through this. Is it clear? And sequentially it will keep on shifting, and it will remain in this position for some time till it measures. Clear? Have you understood, all of you?
Yeah, it's clear.
Now another is a label type. What is the label type? It involves the comparing the sample, each crank chamber in terms with the clear air. It compares with the clear air. It does not compare with the other unit. Each chamber, it will sample will be taken. It compares. It means the reference cell there is air, and the measuring cell, a particular unit, mist. So the engine where there is a high background of oil mist and little or no subdivision, that in the crankcase there we do use this. 4-stroke engine, that is a medium space trunk piston engine, we do use this kind of arrangement, because what will happen in 2-stroke engine, you, because there is partition a frame, so you can compare with one unit with the other unit. But 4-stroke engine, the crankcase is connected, all the crankcase. So what will happen, if you take a sample from one particular unit, then it will be mixed with the other unit. So you will not get the right values. So what we do, we take the sample from one unit and then it compares with the air, fresh air. So in this case, the reference tube is we have the fresh air. This is the fresh air. And this is the sample. We have the rotary valve, and rotary valve, suppose it is 1. So one sample is going through the measuring tube. And then this is the reference tube with the air, and it compares exactly the same way. So how much is the concentration, actual concentration of the mist it can measure, because it is reference is taken by the air. Other one, we measure how much is the more concentration compared to the other units. But here the reference tube is having the containing the air. And this fan is drawing the sample from all the unit, but a particular unit is going through the reference tube, and then remaining is going directly to the exhaust. And this exhaust for previous one is, and this one, it goes to the crankcase back, because you cannot release to the engine room. So it goes back to the crankcase, because it takes suction from the crankcase and goes back to the crankcase. And this one also exactly same. The concentration of the air is same. Air is clear, there is no oil, oil mist. So that it measures that how much concentration is actual concentration of each unit. It is measured and it is displayed, and at a particular value it gives you an alarm, so that you know that there is a high mist, there is a problem in the engine. Is it clear to all of you? And the reason being why it is used for the 4-stroke engine, and the other one comparator type is used for the 2-stroke engine. Understood, everybody? Now the next is light. There are other type also. There is light absorption type comparator level. Let me go through the diagram, you will understand. Okay. Now this is the routine maintenance. What are the sensitivity of the OMD has to be checked, and you can adjust the sensitivity. Span you can adjust. Span is the range, and all samples contain sample amount mist, and the lens and the mirror, they get dirty because the sample is passing through this. So you need to clean that. The lens and the mirror. Lens means photocell lens. An extractor fan and the rotating valve has to be checked for correct operation. And in a choking of the pipe, sample tubes are to be clear. Blow through has to be done with the air, so that we know that sample tubes are clear. And clean and check the rotary valve for proper working. And function test and the follow the maker's instruction. The function test mode you can see, and when there is an high level alarm, then what will happen, it will stop at that point. So you know that from that particular unit it is, the alarm is coming. So then it will not rotate, it will stop at that point. Then we have the light scatter type. in that case, what happens? The light scatter means we have the uh, oil has a property to reflect the light, and once it gets reflected, then what will happen? That light energy, if you can capture in a photocell, then we can compare it. It will be like this. So there are oil, and the light is passing through this, and we have the photocell here. And then you have another photocell here. So this light ray, what will happen? It will get reflected. And depending on the how much is the oil, and remaining will go to this photocell. So this is also photocell, and this is also photocell. So what will happen? This energy is measured. How much is the reflected? So that much actually you can convert into oil concentration. How much it is, the mist concentration, and this much will be reduced. This much will be reduced here. You can compare also that how much is reduced. So that is like this energy is known to us, the light energy. So this is how much you have received, and this much is received. If you plus this two, you should get this. So this is the value of the mist concentration. So this is the one of the scatter type we can use. The advantage being it gives a more accurate value. Another is you can have the exhaust fan, crankcase exhaust fan, which remove the mist, and then it's sent to the mist chamber on the funnel, the oil mist chamber. There it gets released. Then you have another one, but those first two what you have seen, that is okay. This is a scatter type. You can see that is the receiver is at a certain angle, and you have the compensation receiver on the same line. Now what action will be taken in this condition? So if a routine inert gas is used for the crankcase, many of the ships, engine is designed nowadays, modern engine, the crankcase is having the inert gas. So that, because crankcase you don't need air. If you have the inert gas, there will not be any explosion. And venting of the crankcase compartment rather difficult, and a risk of personal exists. So it is the inert gas has been charged. And then when you open it for the inspection, then you'll have to follow the any you are following the this thing, the enclosed space entry, but you'll have to ventilate properly. Now crankcase relief door. The crankcase explosion relief door, it is fitted to a diesel engine crankcase and consists of a light spring loaded non-return disc valve for simple construction, and a light spring so that inertia effect is not minimum, so that it opens quickly. And valve disc is aluminum alloy, reduces the mass inertia, and it can overcome when opening and closing valve rapidly. That's what we want. And large diameter spring is used, so that sensitivity, so it allows to float the valve so that it can open and close quickly, it does not get stuck. And the absence of the valve spindle, there is no valve spindle, so that it can eliminate the valve getting jammed. And valve landing face, makes gas and oil tight seal, because inside you have the gas and oil, and close it is when it is closed, and it is a non-stick stick oil and heat resistance rubber ring is fitted on the disc face, and so that it does not get deteriorated, because it non-stick oil and the heat resistant. An external aluminum valve cover, a secured valve spring, and then it acts as a deflector. You all have seen that there is a deflector, so that it does not, when it is released, then it should not, somebody is standing near to that, it should not be directly hitting to him. And it emits in an arc of 120 degree, and so that it damage less. Also, it can, when it is guided by in one direction, if it is otherwise what will happen, it might hit the equipment also, it can damage, personal injury, all this thing can happen. So it can be of a dome shape. There are different types. Let me explain the one which is means both the diagram. Let me explain the diagram. It will be easier for the description to go through. So this is the inside. In this case, this is the crankcase, and this is the engine room. And this crankcase, there are weighted gauge. This is the flame arrestor, and this is the valve, and this is the o-ring, and this is the valve seat. And what happened, this is the crankcase, and this is the deflector, and this is the deflector is secured by these bolts, and this is the light spring and large diameter spring, and this is the deflector, and this is the, once the pressure increases here, then what will happen, this will move in this direction, and then what will happen, the hot gases will come out through this. It will be guided towards this direction, so that it does not injure the personnel, as well as it does not damage the other equipment and the machinery which is situated near to that. And then this is weight type is better. Why weight type is better? Because once it is passing through this, then it is having the oil, so the oil will absorb the heat energy more if it is dry. Suppose it is outside, then it will be dry, and in that case the heat absorption capability will be less. So here in this case, the oil, it is soaked with oil, so the oil will absorb the heat energy. So this is the sealing ring, and due to the pressure, now let us see the description. So when oil mist, it means the crankcase where it become weighted with the oil mist and splash from the adjacent bearing, then what will happen? This weight oil gauge dissipates the heat greater the rate than becoming. It will be more heat energy it can take, so that the flame trap, it will become flame trap, so that effective flame trap can be it will give you effective flame trap, so that the when it is released, only the gases will come out, the flame will not come out. And free area of the gauge at least the equal to the area of the opening of the valve. Free area means the holes, if you add all the holes, that is the free area through which the gases are coming out. And valve assembly is secured to the aperture cut, and there are a number of cover studs, the deflector we have seen, and then the guide, this valve disc is guided by that stud. There is no this spindle for this valve. If you see, this is the guide. So when valve is opening, this bolt bush will be giving the guide to the valve. So valve will not get stuck, because it is free floating, because large diameter is kept so that it can be free float. It will not twist. It will not move in this direction and in this direction. And this is the description, is same thing is written. So the valve spring is designed to allow the open of an internal pressure approximately 5 kilonewton per meter square will close automatically. The pressure has been relieved. And then crankcase door is robust so that it does not get damaged because inside the pressure is high and it can operate to release the pressure. And valve will require little maintenance. But it has to be tested periodically by hand. You can push by hand and it will open because spring is light spring. And you should inspect the gauge, that is the flame arrestor or the flame trap, whether it is clean or not. This is another type of the this is outside the crankcase. So here this is the A-frame and this is the valve seat and this is the your spring and this is the valve disc and this is the O-ring. So what will happen once this pressure is high, this valve disc will move in this direction against the spring, and here also there is no spindle, so it will be guided by this bolt. And then the gases will be removed, released through this, and this is the flame arrestor, and this is the deflector, and this is the spring. So this flame arrestor is dry type. So when it's passing through this, the flame, it will get trapped here, and then only the hot gases will come out, not the flame. So this is another type of crankcase relief valve or the relief door. Any question? So this you're talking the shape are you talking about this shape, valve disc shape?
Yes, Chief.
Yeah, that is because if you have the plain and the thin plate, the strength will be less. This strength will be high, like its corrugation it is having. So that the strength, because we need to make it light, but at the same time it will be strong enough to withstand that pressure, so that it should not collapse, fail. So strength is increase as well as the spring to fit. It will sit onto this. Spring has to remain on the same place. So it has to make a shape like this so that the spring is sitting onto this. So both the reason you have this, so that the sidewise, the radially, the spring will not shift. And the strength also is increased. Like curvature, if you have, your strength is increased. Now another abnormal situation is the uptake fire. The uptake fire, so the engine exhaust gas, it contains the particle. What is the particle? Unburned fuel, that is the soot, and which consists of the partially unburned fuel. Also it will have lubricating oil, it will have, because the cylinder lube oil, and ash from the fuel also will have. And this particular can make deposit on the exhaust gas boiler tube. And situation will become worse when there is a low load operation, prolonged low load operation. Many ships it uses that, and then what will happen? Reduces the velocity. because the velocity across the exhaust gas economizer is important. So that with that velocity, it impinge the exhaust will impinge onto the uh, surface of the tube, outer surface, as well as what will happen with the high velocity, there will be an erosion effect, so that it will not allow to make any deposit. But low load operation, the engine, then what will happen, the velocity of the exhaust will reduce, and it will not attain the sufficient velocity to remove those deposits. The deposit will be high. That's why you see the low load operation, your combustion also poor and the deposit also will be high, and lead to the soot deposits. And burning poor quality of fuel and poor combustion, what will happen? The defective injection equipment, suppose, and low load, the unburned fuel will be more, and insufficient, suppose the fuel treatment is there, then it will create a soot deposit sticky, because there will be incomplete combustion. And then what will happen, exhaust gas, it contains a spark, suppose, and it will ignite the soot deposit, because 15% of the oxygen is required to have the fire. So the gas generates a fire in the deposits, because oxygen, we supply the excess oxygen to the to our combustion chamber. So there will be always oxygen in the exhaust. So the exhaust gas boiler runs dry, suppose, then what will happen? It means the water is not there in the exhaust boiler. Then any deposit on the tube will quickly heat it up, because that tube will be, there will not be heat exchange. So the deposit will get heated up to the exhaust gas temperature. Then what will happen? Excess oxygen is already there. It will get oxidized, will oxidize the deposits, and this deposit temperature will rise, because oxidation is the, these are exothermic reaction. Then what will happen? It can reaches to the self ignition temperature of the soot, and then soot deposit ignite by glowing carbon particles and in the exhaust, and ignition temperature of the soot usually less than 400 degrees centigrade. But the sticky deposit on the unburned fuel will reduce that to 200 degrees centigrade, and then the ignition, there will be the uptake fire. And the possible for the soot fire to occur, the engine has been shut down. It is important. It means if there is a soot fire, then engine has to be stopped, and the circulation of water has to be circulation after the shutdown of the engine. And what are the symptoms? Symptom is the, it activates the and rapidly rising the boiler pressure, uh, because of this fire, the heat will be added to the water, and the rapidly, suddenly, you will see the boiler pressure is increasing. Then risk of fire will reduce. How you reduce? You monitor the pressure drop across the exhaust boiler. Then the exhaust will attain the correct velocity, so that it will not make deposit. And even if you know that there is a deposit, in port you clean it. You do the exhaust boiler washing. Carry out the regular soot blow also during the passage, so that it will not allow soot deposits on the surface. And water washing has to be done regularly, and maintaining full water circulation, so that there is no tube is dry. Then operating in soot fire situation, if there is a soot fire, then what will happen? The recommended, and the depending on the level of the fire, there are level 1, level 2. So the level 1, the initial soot fire, it has happened. So in that case, just it has been discovered. In that case, stop the engine, and oxygen supply to the fire is stopped. Stop the auxiliary blower. cover your the inlet filter, turbocharger inlet filter, and continue operating of the circulating water pump. Do not stop that because the residual heat has to be taken out. And then start the standby pump so that the mass flow rate you can increase, more heat energy can be removed. And then never use the soot blower for firefighting. If you are using the soot blower, suppose it is with the compressed air, the fire with oxygen. You are supplying the oxygen. If it is steam, it can risk of high temperature fire. So do not use the soot blower. And then stop the air circulation through the engine, so that you cover it. You have already covered it, so that you have stopped the auxiliary blower, turbocharger you have covered, so that oxygen supply to the fire is stopped. And keep air pressure on the diesel engine exhaust valve closing mechanism. Suppose you have all unit will not be closed. On medium speed engine, if the rocker arm control the exhaust valve, turbocharger inlet should be smothered. It means turbocharger inlet is closed. Then water washing, if fitted, can be used to extinguish the fire, but it is ship's firemen you can use, but it has to be in the jet form, not in spray form. Then there will be a high temperature fire. And the soot blow has to be done regularly. It is probable that any fire, it starts small. So this remember that the exhaust boiler fire you should detect at initial stage and extinguish. And above, emergency action is taken immediately and fire is quickly extinguished. Should not go to the level 2 situation. If fire cannot be controlled in this way, then what will happen? There will be a level 2 fire. So in that case, what will happen? The fire, that will be metal fire, and then the tube will get ruptured. Suppose the tube will get ruptured, then what will happen? So suppose there is a tube heat damage to the tube. So if you should not go to that stage. So the circulation of water will keep the tube cool and reduce any heat damage causes by the fire. Now the level 2, that serious high temperature soot fire, that is the level 2, which will destroy the tube. And even it will not only deform, it will rupture. And what will be the indication? You will see the feed water consumption has reduced. It means the hot well level is reducing. It means there is a rupture of the tube leakage. So in that case, what will happen? A temperature sensor also, which is at 400 degree, will normally the high temperature will give you an alarm that there is a high temperature that reaches to the 400 degrees centigrade. You will see that the water consumption also is increased. So that is the level 2. But remember always, do not go to that level 2. You must extinguish before that only, level 1. So where the boiler tube has melted down, then stop the main engine. If not, stop already. And stop the circulating water pump, because now you cannot use the circulating water pump. Close, because water will go inside and then there will be a high temperature fire. So the close valves and water circulating line inlet outlet, and drain the remaining water from the exhaust boiler, because there should not be any water. Extinguish with the jet of force of water, and heart of the fire you need to put the jet while standing by with the boundary cooling. Do not do the boundary cooling, only stand by, because boundary cooling, if you start, then there will be stability problem, other equipment may get damaged. So only in case of extreme emergency, then you will be using that. Then soot fire turn into high temperature fire, it can happen that hydrogen fire or the iron fire, metal is melting now, and then the very large quantity of heat energy will be released. So using the water fire extinguisher, that is very important. It has to be jet, not in or not in atomized form, that is a spray form, as well as it has to be heart of the fire, directly it has to be applied. Then the fire will be extinguished. So main aim, one discovered an initial small fire, that should be the main aim, and discover at small stage initial fire so that you can extinguish and prevent it turning into a high temperature fire, which is a very dangerous thing. Any question till now? Yeah, Mesfin, tell me. Mesfin, you are not coming clear. Just check your internet.
We cannot use
Say again. Mesfin,
Chief.
tell me.
During can you hear me, Chief? Can I continue?
Yeah, now I can hear you. Tell me. But you are coming in between
During
broken.
metal
Yeah. During metal fire,
we cannot use. We
say.
cannot use any extinguisher to extinguish the fire.
So there is no extinguisher at that point. On your ship, apart from the fire line, was there any extinguisher? Because this you can use the dry powder. Because metal fire, you can use the dry powder or sand. Sand is kept for the boiler. In exhaust boiler, usually the sand is not kept. If there is a sand, you can put the sand. But the problem is it will fall down. That is the problem. So it is the jet of air with the sand you can use to extinguish the fire. It will cover the metal, and provided that sand, it can be accumulated there, because you don't have access to that. You cannot go inside. So whatever you'll have to do from outside. Metal fire, you can use sand, you can use and mostly it is used the sand, and in that case you'll have to use the water. Mesfin, is it clear? Have you understood?
Yes, Chief. The question was about the chain reaction, but if we can use this powder, then means all this.
Yeah. So that's why that is the problem of using the other extinguisher. It is done by the jet of water. That's the reason it has been repeatedly I'm saying that the ship should not go to that stage, because early stage it has to be detected and extinguished. Yeah, Samuel, tell me. Samuel, you raised your hand. Tell me. Okay, Samuel got disconnected during the oil limits detector. Okay, let me quickly explain. Okay, Samuel, I am explaining. Yeah, Addis office, you have any question?
Yes, Chief.
Yeah, tell me.
In freshwater generator, the seawater supply line is not clear, because only seen on the diagram, the seawater that out from the condenser only. Where is the seawater supply pump that supplies the seawater to the condenser? I didn't understand.
Okay, So I'll explain that. I'll show you the diagram and explain. Now Samuel actually missed this oil OMD. So OMD as a comparator type has got two tube. One is reference tube, one is the measuring tube, and that is a rotary valve. Rotary valve is rotating and it stops for some time to one point, and these are the sample. It's coming from all the units. This is 1, 2, 3, like this, 4, 5, 6, 7, 8, 9 units. So what will happen? This rotary valve is taking sample from here and it's passing through the measuring tube, and remaining all unit is going to the reference tube. And there is a mirror here, and there is a photocell, and this light is here, and there is a mirror here. So what is happening? This light is projecting onto the mirror, and then it is passing parallel to this tube, and this is also passing parallel to this tube. Now this sample, the all other unit is passing through this. It has got a concentration, and this particular unit has got a concentration. So these two are compared. When it is passing, light is passing through this, what will happen? Light illumination on the photocell will be based on the concentration. So if the concentration is same, both the illumination will be same, there will not be any output of the from the circuit. It will be balanced. If the illumination is different, suppose the number one unit, the concentration is high, then what will happen? Compared to the rest of the unit, then there will be a less illumination here. So there will be a current flowing through the circuit, and it will be measured value will give you that how much is the difference. And at predetermined set value, then once it reaches, it will give you an alarm. And next moment it was stopped here, then it has shifted to this. So once it has shifted here, then what will happen? So number 2 sample is now passing through the measuring tube, and rest other unit is passing through the reference. So next time number 3 will be passing through the measuring tube, next number 4, like that. It shifts and stops there. And if there is any alarm, it will stop at that point. So we know from which unit the alarm is coming. As well as this fan is taking the sample, this will go back to the your crankcase, because it cannot be released to the engine room atmosphere. This is one type, and the other type is the rotary valve. You have the same, but only thing, the reference tube now it's containing air instead of the other unit sample. So the each unit is sampled, is passing through the measuring tube, and the reference tube is air, so that it is sealed with air. So it is comparing the concentration with the air exactly the similar way. So actually how much is the concentration it is giving. So this is the level type oil mist detector. And once the concentration, and it will show the value, actual value, it is not relative value. The previous one is the relative value. And then what will happen? At default set value, once it reaches, then it will stop at that point, and then it will give an alarm. And if it is connected to the slowdown, engine will slow down. So this is the difference between the both we use. This one we use for the 4-stroke engine, because crankcase is common. So you cannot compare with the other unit with the one unit. But 2-stroke engine you can do it. 2-stroke engine, because of the each crank throw is partition is there, because of the you have the transverse girder, and on top of that you have the A-frame. So each crank case is the crank throw is divided. So there we use the comparator type, and for 4-stroke engine we use the level type. Is it clear, Samuel? And
Chief.
yeah, tell me.
What is the purpose of the other tube, which is going to the fan on top of the reference tube?
This reference tube continuously the sample is taken. Otherwise, what will happen if the sample is not taken? Then there can be accumulation of the tube. There can be a blockage. So that's why continuously, because it's taking the suction and it ensure that the lines is clear, and then it's going back to the crankcase again. So that is the reason the other tubes also the is it's drawn, gas is drawn, but it is not as a sample. It goes back to the crankcase so that it ensures that the passage are clear. Yeah, Samuel, you have raised hand. Any question? So let us take a coffee break for 20 minutes and then we'll start at 3:20. We'll start again. So good afternoon once again. Yeah, good afternoon once again. So let us start again.
Good afternoon, sir.
Yeah, good afternoon. So next is the explosion in the exhaust trunking and the uptake. So during the normal operation, so there are sufficient considerable amount of Ig is there in the exhaust trunk because you have the CO2, nitrogen, and if any unburned fuel is present, an explosion will be unlikely because there are sufficient inert gas is there in the flue gas. We have seen that we use the flue gas as an inert gas for the tankers. So the engine, now the problem is, suppose the engine is started following a short stop. Suppose the engine has stopped because of the maneuvering, it has stopped, and then or during the long sea passage, it has stopped after that, and then after short stop, the engine has restarted. Then what happens? The exhaust manifold is still very hot. It did not cool down, and then there can be a possibility of explosion in the manifold, exhaust manifold. Why it is so? Because there are ignition of the hydrocarbon gases, because in the manifold still have the hydrocarbon gases, and you have the temperature is high. Now what will happen? Suppose there is an accumulation of the unburned fuel in the exhaust trunking, then what will happen? That will evaporate because of the high temperature, and then you restarted the engine. Then what will happen? Because of restarting, it is air start, so this air will go to the exhaust manifold. Now you have the heat, you have the fuel, and air is going to the exhaust manifold, and that can cause an explosion in the exhaust trunking or the exhaust uptake. So this has been found for some vessel, especially because previously we were not running at low speed and slow speed or very slow speed. We are not running at that. We used to run at economic speed. This concept of economic speed for a long time. Japanese owners, they used to run an eco speed. But now because of the recession, the ship are running as a low speed, very low speed. So in that speed, there is unburned fuel, and then that can cause this kind of explosion. We experienced many vessels because of the accumulation of unburned fuel on the, and then when you restart it engine, then the explosion occurs. So the risk of such explosion is higher after prolonged period of slow running. When you have the slow running and the fuel consumption, that is combustion is incomplete combustion due to the slow running, then how do you avoid this possibility of explosion in this case? Like the slow turning, what you see today, it was not there earlier because it was not required. Ship used to run at full maximum speed. In fact, it used to be lost for the owner if it does not, she does not run at maximum speed. So the possible explosion we can avoid. So dangerous gases should be expelled from the manifold. If the dangerous gases is expelled from the manifold, then what will happen? That fuel will not be there. Then there will not be a explosion. So that is the reason the engine slowly is turned by the air before startup. Before starting the engine, we have the slow turning. It means in one revolution in 1 minute we achieve. It means one RPM we achieve. So the amount of air is turning the engine very less. So a slow turning valve is provided, which is a bypass of the main auto air start valve. bypass of the air stud valve, there will be a small diameter pipe and the valve which will cause the slow turning of the engine, and the supplying a much smaller quantity of air is fitted this purpose. It means for starting an engine, you have the main auto air starting valve. You put a bypass valve to that with smaller diameter, smaller valve, and before starting the engine, you start with that, means turn the engine with that, so that the with that pressure, the hydrocarbon gases, which is fuel, will move away to the atmosphere, so that the explosion will not happen. And suppose engine had stopped during the maneuvering, and the 30 minutes there is no movement from the bridge, then what will happen? The slow turning valve will open, and the engine will turn that at 1 rpm, and after that the engine will start. It means the it will clear off all the gases from the exhaust trunking and the manifold, so that there will not be fuel, there will not be explosion. Clear, understood all of you? Any question on that? So next is air starting line explosion. Now, how the air starting line explosion occurs? For fire to happen, we all know that there has to be a fire triangle, and fire triangle is one side is the heat, one side is the oil, the one side is the fuel, one side is the, and the third side is the oxygen. So the to complete the fire triangle, you need three things, that the heat, fuel, and air. And in the air starting line, you have air always, because it is the air starting line. And the air starting system of the main engine, fuel can be present. Fuel will come from where? That is the lube oil. Lube oil, when it carried over from the compressor, and if suppose the separator is not working correctly, and it carry over to the air bottle, and air bottle is not drained properly, then that will carry over to the air starting system, and this lube oil is fuel. And oxygen is present in the system in plenty, and the heat source will come from here. Where? Suppose your air starting cylinder, air starting valve is leaking, then what will happen? There will be a heat source, because during the combustion, the heat will come into the manifold or the branch line. So this cylinder head valve is leaking, then combination of these three will lead to a airline explosion, air starting line explosion. This branch pipe to the air starting manifold, so heats up to the red heat, you can see. That's why during the this is the consequence what will happen, because of the leakage of the cylinder air starting valve, the branch line will be red hot, it will be heated. That's why during the round you check whether it is heated up or not. And in that case, what will happen? Engine is stopped and restarted before the pipe has been time to cool. So any oil vapor in the air, what will happen? Will ignite, and explosion can result, because of the mixture of the oil and air is correct proportion. We know the flammable range. In that range, if it is, then it will have a ignition and explosion. And this explosion, what is the problem with this explosion? When it happens, then the air starting line will blow off, and then will crack, or the starting the fire on the engine room. Machinery space will be having the fire, because suppose the air starting line get ruptured, and the personal injury also will be happening, because if the pipe get ruptured, then what will happen? That pipe pieces will be flown out, and it will be if it hit by somebody is hit by that, then he will be injured. Now, what is the prevention? So the prevention is all safety. There are safety devices. All safety devices has to be in air starting line. Safety devices has to be in working condition, and draining of the oil bottle is carried out in each and every watch. so that the oil accumulated oil, because bottle, if you see the bottle, it is in cooler space. What will happen? Bottle, the water will get condensed and it will get dropped, and oil also will get condensed, and then it will fall down at the bottom, and then through the drain it comes out. You drain it periodically so that you remove those oil and water. Then auto drain should be proper functioning. There are auto drain for the compressor as well as the bottle also can auto drain. Auto drain is nothing, it is like a float. When the water and oil gets accumulated, float moves up, and then the drain is open and the liquid gets drained out. And once the liquid gets drained out, then the float will move down, and with the air pressure it gets closed, the line gets closed. And this has to function properly so that the oil and the water gets drained out from the system. And then there are other drains also on the main, means the air starting line. There are drains provided, you can drain it manually. And the air compressor is well maintained and avoid oil carryover. There will be oil carryover, but you should minimize the oil carryover. So that if the air compressor, suppose the piston ring is leaking and your feed rate is high for the lubrication, we have seen that air compressor part, then what will happen? More oil will go into the cylinder side, and there will be carryover, more carryover. And the oil separator at discharge of the compressor is working efficiently. That is the aftercooler and the intercooler, where it gets separated and then it gets drained out. Then the starting air manifold pipe to be cleaned and checked for paint deformation. So if any paint deformation, you can suspect that there is a leakage in the, it means heat is overheated, pipe is overheated, and heat energy will come from where? It will come from the valve leakage, or there is some explosion or some heat energy inside the inside the air starting line. And the heat source we have seen, it is from the your cylinder air starting valve leaking. Starting air valve to be overhauled a regular interval to avoid the leakage so that it does not leak. And then starting air valve seat to be inspected and lapped so that it does not. Also, starting air valve should be assembled properly. If you over tighten the spindle, then what will happen? Spindle will have a bend. And once the spindle will have a bend, it will remain in open position. So there are proper maintenance has to be done for the cylinder air starting valve. Then the precautions is safety devices. What are the safety devices you have in the air starting line? So that if there is any explosion, then still the pipe will not get ruptured. So that safety, there are certain safety devices is provided. Relief valve. Relief valve, where it is fitted, it is on the common air manifold. Air manifold, nothing but a pipe. You have a pipe which is from fore and aft, and then branch line is going to the individual cylinder air starting valve, and that common pipe is called a manifold. And the relief valve has to be fitted on the manifold, common manifold, as per the SOLAS requirement. And this relief valve it is at the air manifold, and it is fitted at the end of the manifold. So end of the manifold, you will be having the relief valve. So if there is any excess pressure, from where the excess pressure will come, if there is any explosion, then there will be excess pressure, relief valve will lift, and then excess pressure will be released to the engine room so that the pipe will not get ruptured. The advantage of relief valve, once relief valve lift, excess pressure is relieved, again it sit back. So that during the maneuvering or traffic, still you can run the engine. So there will not be any problem on the air starting pressure. So that is the advantage of using the relief valve. And Sulzer, that is Wärtsilä, uses the relief valve, whereas the B&W does not use the relief valve. So the relief valve is spring-loaded, normal spring-loaded valve. So it lifts against the spring when the pressure is more than the said, reaches to the said value, and then the excess pressure is released. Again, what will happen to the manifold? Manifold pressure will drop and then it will close at that point. And again, you can use the engine for starting. Now the bursting disc. Bursting disc is where it is fitted. It has to be fitted in the starting air pipe, and individual unit has got the bursting disc. And there is a perforated disc and a sheet of material. One sheet is perforated, you have the perforated disc, and there is a protected by a sheet of material. That sheet is the bursting disc, which will burst when there is a excess pressure. When there is excess pressure, this disc will burst, so that the excess pressure will be released. The problem with this, then once the bursting disc is ruptured, then continuously the air will get released. But in case of emergency, you should be able to run the engine, because suppose in traffic maneuvering, then you cannot stop the engine. Then what you do, that the it will, if there is any explosion, there is a problem. But still, in case of emergency, you can block that perforated disc, that hole can be blocked by a cover, so that you turn the, it means that protective cap, you can turn it and you can block those holes, and then still you can use the unit, that particular engine, you can start it, but you will know that which particular unit the bursting discs are burst. So you can, there will be an indicator, and you can get the indication, and then you turn it. So this will ensure that the maneuvering and the traffic air, during the traffic, air is available of the engine. Non-return valve. What is non-return valve? Is it is a requirement. The maneuvering system, air starting system, has to have a non-return valve. This is positioned where? This is positioned between the air manifold and the air receiver. What is the purpose of it? Purpose of it, so if there is an explosion, if you don't have the non-return valve, then what will happen? The flame and the hot air will go to the cylinder, the air receiver. Then what will happen? Air receiver will blow off. So that is the reason there is a non-return valve which is placed in between the air manifold and the air receiver. For an example, if you see for the BMW, it is auto air starting valve. Before that, there is a non-return valve. And then you have the this thing, the soldier uses the auto air starting valve. On top of that, there is a non-return valve. It means it is protecting, it stops the gases to go to the even automatic air starting valve. It is engine and automatic air starting valve just before the automatic air starting valve. So that it is unidirectional property of the non-return valve, so that if any explosion, the hot gases and the flame will not go to the air receiver. Then you have the flame arrestor. The small unit, it is, what is the flame arrestor? Flame arrestor is the several tubes in a plate. You have a plate and there are several tubes inside, and this when the flame passes through it, what will happen? The heat energy is reduced, and the heat energy of the flame is reduced to such an extent that it does not support the combustion. So the other side, there will not be any flame. So the leaking starting air valve, individual starting air valve, there has to be a flame arrestor, so that any valve is leaking, the flame will not go to the your air starting manifold. So now let me draw this, you will understand. So this is your so this is the air starting line which is going to the engine, you have a flange here, and on top of the flange you have the so you have a disc here, and you have a cap here. On top of that, you have a cap. And this cap is perforated. It means there are holes. There are holes, and there is a cover. So this cover this is the cover, and this cover has on top, it has got a screw. And this cover, that green one, you can turn it. Angular motion you can have, you can turn it. And green also has got the hole. And when it is in use, that time this hole does not match. This hole is here, this hole is here, this hole is here, and this hole is here. So this the hole for the cap is open. Now suppose the bursting disc has burst, then what will happen? You will be turning this green so that the green and this hole, they cover. It will get covered, so that there is no passage now. And how do you know that individual unit will be having a bursting disc? How do you know which one has been ruptured? So there is a plate. So there is a plate here. So what will happen? Once there is a leakage, this plate will get deflected once the bursting disc has burst. Because with high pressure, the pressure will release through this hole, and this plate is covering two holes on opposite side. So it will get deflected. By seeing that, you know that this particular bursting disc has burst, and then you turn it for emergency use. But it is only for the emergency use to make port. Once you reach to the port, you change the bursting disc and you rectify what is the problem, actual problem by which the bursting disc has burst. Clear? Any question about the bursting disc? An individual unit has to have which is branch line, it will have which is going to your cylinder head. And now the non-return valve. Non-return valves, for an example, let me draw one. So this is the automatic air starting valve for a soldier, for an example. On top there is a non-return valve. So this is the valve seat, and there is a non-return valve here. So this is going to the engine manifold, and this is coming from the there will be a supply from the your air bottle. And then once this valve is open, this automatic air starting valve, then it has to pass through the non-return valve, and then it goes to the air manifold. So this is the non-return valve is provided, so that if there is any explosion, this is the manifold. If there is any explosion, pressure will increase, that flame will not go to the air bottle. So that is the purpose of non-return valve. And the flame arrestor is like this. So it is a circular plate which is having number of tubes, circular tubes. So this tube, and this has got a thickness, and this tube is through and through. So what will happen once it so this has got these tubes are there, it is passing through this tube. Once it passing through this tube, what will happen, it will absorb the heat energy, so that the other side, once it passes, suppose this side is the engine side and this is the manifold. So once it is passing through it, then the heat energy is reduced of the flame front, and then it will reduce to such an extent so that it will not support the combustion, and it will get extinguished when it is passing through that. So that the other side, there will not be flame in the manifold, there will be hot gases but not the flame. Any question till now for air starting line explosion? Any question? So now, if no question, then now the turbocharger surging, how that surging occurs. So what is turbocharger surging? So if the air pressure after the compressor, because we have a compressor which is drawing, inlet is from the engine room and then outlet is going to the air cooler. So if the compressor delivery pressure is higher than the compressor can internally maintain. The compressor, you see there is no suction valve or the delivery valve, but still flow is from unidirection. In normal condition, from the inlet through the delivery, it goes to the air cooler. Now, but your delivery pressure is higher than the inlet pressure. Tell me why there is no flow to the, in normal condition, what will happen? From higher pressure, the flow will be to the lower pressure. But in this case, if you see, it is not that. Why? Tell me, is the question clear what I asked?
No, Chief.
Yeah. Yeah, tell me.
Pressure inside the scavenge space is higher.
Yes, scavenge space is higher and the suction side is the engine room. Then why there is no flow? There is no valve in the compressor. Is there any valve? It is a passage is connected. That is my question. Higher pressure is on the scavenge space and lower pressure is the inlet to the turbocharger air side. But then why there is no flow from the higher pressure to the lower pressure? Just think and answer.
There is non-return valve inside.
Where non-return valve? You're talking about the manifold, that is the scavenge manifold.
Yes.
But before that, what will happen? The pressure is same. Your air cooler, air side pressure is same as the scavenge air pressure, isn't it?
Compressor is running, Chief. Compressor is imparting.
Yes. So the Abebe, tell me.
The pressure after the compressor is not more than the capacity of the compressor.
Yes. So what happened actually, it is what Abebe and the Marge tried to say, compressor has a holding capacity, internal pressure, how much it can hold. It means you have a compressor, it is taking suction from the engine room and it is delivering. And as per the design, compressor will have that is the capacity. The rated pressure, it should be able to hold that pressure internally inside the compressor. It means if your pressure, the delivery pressure is equal to that pressure, then there will not be any flow. The moment it is more than that pressure, then there will be a flow like this. Suppose this is the compressor, and in this compressor, this is the delivery. Suppose this is the delivery, and this is the suction from the engine room. It has got a pressure, that is the atmospheric pressure, P1, and this is P2 is the delivery pressure. Now, there is a pressure as per the design which the compressor will be able to hold. It means it can hold that pressure because when it is running. Now what will happen? Suppose P3 is equal to P2. There will not be any reverse flow. But the moment P2 become more than the P3, then this pressure will break. It won't be able to hold more than P3. So what will happen? There will be a reverse flow of the air. So the pressure of the air delivered by the compressor, if higher than the pressure inside the compressor, which it can hold, then there will be a reverse flow and air is created towards the impeller. And then what will happen? Which reduces the speed of the compressor, because compressor is running in one direction, then there will be a reverse flow. It will oppose the direction of rotation, rotational direction, and it is opposite to that. So the you'll see when there is a surging, the RPM of the turbocharger drops because of that reason. And what else you will have? You'll be having the it will become imbalance. It will create noise because your the shaft, that rotor will try to come out. It will get imbalance and there will be vibration and noise, and it will affect the bearing. The bearing will be overloaded, and even bearing can get damaged if continuously surging occurs. Now the surging, what will happen? It will sharp fall in the flow because there is a reverse flow. Now the supply of air will reduce. There will be sharp fall in the flow and acceleration of air, mainly because of the reversal of the pressure. So there will be a reversal of the pressure, and there will be a acceleration of that pressure. With high velocity, it will come out, and you can see that your felt filter it's trying to come out because of the reverse flow. Now the imbalance in the demand and supply. What is demand and supply? Engine, at each load there is a design supply quantity of air required for the engine to maintain the air fuel ratio. Now what will happen? Suppose the demand and supply, and demand is demand by the engine and supply by the turbocharger. Now the demand by the engine at a particular load, it has to match with the supply of the air from the turbocharger. If it does not match, actually the engine is designed accordingly. Only thing, when you are using the constant turbocharger, then what will happen, you have the at low load, the demand is high than the supply, and the auxiliary blower you use for increasing the demand to meet the supply. At higher load, the demand and supply is matched. What is the actual operating range? That up to that, it will demand and supply will match. The design is of the engine and the turbocharger is such. So suppose there is an imbalance, the demand is less and the suppose demand is less and the supply is more, it can happen. So what will happen, then the pressure, the supply of the air will not be consumed by the engine completely. Then what will happen, the scavenge pressure will build up, and at one pressure, that P3 what I have shown, that the internal pressure of the turbocharger will exceed the delivery pressure, and then there will be a reverse flow. Now that's why this demand and supply, it has to balance, it has to match and lead to, if it does not balance, then if it is imbalanced, then what will happen, there will lead to be a turbocharger surging and can damage to the turbocharger, especially the bearing get damage, it can seize to the turbocharger rotor. It has happened, there are occasions because of the continuous surging and very high pitch of surging, the turbocharger rotor got seized in the bearing. And surging is to avoid, that's why the interferes the combustion of the engine. It means the demand and supply does not match, then what will happen, that will interfere the combustion of the engine. The combustion of the engine should be correct, so that because your you see the supply is by the turbocharger, and turbocharger will supply according to the load demand, and that will depend on the RPM. It means when it is designed at particular RPM, the load of the engine, you have the exhaust temperature, and that will decide how much will be the RPM of the turbocharger, because you are using the exhaust gas. So if it gets imbalanced, it means the turbocharger RPM does not match with the particular exhaust at that load, what should be the exhaust. If that exhaust is not at that load, which should be as per the design, then what will happen, where there will be a variation of the turbocharger RPM, and there will be a mismatch with the demand and supply. So the combustion is one of the very important factor, and turbocharger surging affect the performance and reduces the efficiency of the engine and cause the damage of the bearing. Bearing, most of the cases, the bearing will be getting damaged if you don't take the necessary action. The surging, if let us see one of the characteristic compressor, that is the turbocharger compressor side compressor characteristics. We can see flow rate, air flow rate with the pressure ratio. So this is the curve we have. This is the centrifugal compressor. Now tell me, this curve is the pressure ratio, that is the inlet and outlet pressure ratio, that outlet pressure divided by the inlet pressure. Inlet pressure is the engine room pressure, outlet pressure is the delivery pressure. If you take the ratio of that, then delivery pressure divided by the engine room pressure, that is the pressure ratio, and versus the flow rate. Now tell me, is there any difference you can find out? The pump section, you have seen that the characteristics curve, that is the HQ curve, and this curve, what is the difference? Is there any or same? Both are centrifugal blower. This is centrifugal compressor and that is centrifugal pump. Working principle is same, but the characteristics curve shows something else. Is it the same or there is different? Anybody? You have seen the characteristics curve of the pump, and now I have displayed the characteristic curve of the compressor of the turbocharger. Any difference? Yeah, Abel, you want to say something? Yeah, tell.
The blower, this centrifugal blower has higher.
Yeah, tell Abel, your microphone is off.
This centrifugal blower has this higher RPM.
Yeah, RPM is high, but at constant RPM, it has been drawn, this curve, like centrifugal pump characteristics we have seen. But is there any difference in that? Let us see. Okay. Now, what we have seen in the centrifugal pump, this was the delivery head and this is the flow rate. This is Q. Here, this is the Q. And here it is pressure ratio and there it was head. It is the same thing, delivery head. Slightly because it is compressor, that's why it is it has to be characteristics curve will be like this. Now what we have seen for the centrifugal pump, the characteristics curve was like this. So this is the H and this is Q. What we have seen, the H reduces, suppose H is here, Q reduces. H is here, H is reduces, Q increases. And maximum Q you get it at no head. And when head is at one point, the delivery head is very high, then what will happen? Q will be 0. There will not be any delivery, it will be stall. There will not be any movement of the fluid. But whereas in this curve, let us see. Let us take one curve, this curve. So this is the pressure. Suppose we take this H and this is Q. This curve is moving in this direction. What does it mean? The head has increased. What happened to Q? Head has increased. Here, Q has increased. Have you noticed that? This is the head. Q is here. And at this point, head has increased. What happened? Q has increased. This one is just opposite. It means this is not normal. If the head increases, Q should reduce. But whereas for the turbocharger compressor, centrifugal compressor, this is the characteristics. The head increases, Q increases. But at one point, at this point, if you see, what will happen? This is the Q at this point. And after that, let us see the curve. Now, the head reduces, Q increases. If you see here, we reduce further head, the Q reduces. So what does it mean? This side of the curve is not normal, whereas this side of the curve is normal. So we can cut this, divide this curve into two portions. One is abnormal, one is normal. Behavior of the compressor is like that. We cannot help it. This is a characteristics curve. That's the way it behaves. So this side, left-hand side of this line, what I had drawn just now, it's the abnormal side and the right-hand side is normal side. And if you join this point and draw a line, you will get a line like this. So the centrifugal compressor, we can operate on the right-hand side of this line. And left hand side we cannot operate because it is behaving abnormal, something opposite. So this line is called surge line. It means, what does it mean? When centrifugal blower it's operating condition shift to towards the surge line, and it shifts to the other side of the surge line, then the surging occurs. Whereas on this side, when it is on this side, then what will happen? The surging will not occur. So we should operate the compressor on this side, not on this side. Clear, understood? In what condition the surging occurs. And another thing you see, suppose we draw a line here. This is the head. We draw a line here. At the same pressure, you have two delivery. One is this delivery, another one is this delivery. Whereas centrifugal pump, you don't have this. So we'll have to use this side, not this side. Any question? Have you understood what I said?
Sir, can you explain how surging occurs once more? Because I was having a connection problem.
Okay. This is the characteristics curve of centrifugal compressor. In this curve, if you see the centrifugal pump, we have seen the characteristics curve. That is when the pressure increases, flow reduces. But here, if you see on the left hand side of this line, that the head increases, flow increases. It is something not normal. And this side of the curve is showing like this. But this side of the curve, if you see, the head increases, the delivery reduces. That is the flow reduces. Suppose we draw a line here. So it will be Q is here. And if we draw a line here, so the head has reduced, then the Q has increased. So the right hand side of this curve, it is normal. This side is normal. This side is abnormal. So we cannot operate this compressor on right hand side of this line, which is called surge line. And sorry, left hand side of this curve, which is called surge line. Left hand side of the surge line, we cannot operate the compressor, whereas we can operate on the right hand side of the surge line. So what happened? The operating condition when it is not normal, then what will happen? It will shift towards the surge line, and it will shift to the left hand side, and the surging will occur. So that is the condition. We should not operate the compressor, and it will reach to that condition because of the various engine abnormalities, engine defects. So we should take care of those defects, so that if you run the engine in proper condition, proper operating condition, then this will not happen. The operating condition will not shift to the left hand side of the surge line, and the surging will occur. Is it clear? Have you understood?
Yes.
Okay. Yeah, Marga, you raise your hand. Tell me.
I got confused with this diagram, Chief. In a practical world, is there a condition in which the blower, the flow rate of a blower increases as the pressure ratio increases? I mean, the suction side and pressure at the suction side and the pressure at the discharge side. I mean, right? Pressure ratio.
Yeah, that is the pressure ratio, delivery divided by the suction.
So, Chief, as we increase the flow rate, or as
Yeah.
the pressure ratio between the discharge and suction increases, is there a way we can say volume flow rate is increased?
No, when the pressure ratio, you see your inlet is constant, isn't it? When the pressure ratio increases, your flow should be reduced, because pressure increases, the flow reduces, isn't it? Like centrifugal pump. If the pressure ratio reduces, uh, that pressure ratio means it is delivery divided by the suction, and suction is constant. And the pressure ratio reduces, what does it mean? The delivery pressure reduces, and your Q should increase, not reduce. But whereas left hand side of the surge line, it's just opposite. Is it clear, Marga? Have you understood?
Yes, Chief, but the flow rate is not increasing, right? Discharge pressure is coming up, and flow rate is also decreasing.
Yeah, that is the normal.
Reducing.
That discharge
Yes,
pressure
during
is
normal.
increased. That is normal, because discharge side, discharge pressure increases. Suppose pressure ratio, instead of that, let us think about the pump, that is the delivery pressure. Delivery pressure increases, your flow rate will reduce or not? Your flow rate will reduce. Your mass will increase because pressure has increased, but your flow rate will reduce because the flow of the air will reduce. That is the normal characteristics of any centrifugal blower or the centrifugal pump, for an example. But centrifugal blower, up beyond the surge line, it behaves normal, but before the surge line, it behaves opposite. If your delivery pressure increases, then your flow rate, will it increase? It will not increase, because the less mass will enter now. But you increase the pressure, so your quantity of the mass has increased, but the flow will now reduce because of the pressure.
What if the blower runs abnormally, Chief?
Yeah, then we'll see that then the surging will occur, because the reverse flow will take place. Because it is not in a normal condition. In that case, what will happen? The surging will take place. What is surging? It is the reverse flow of the, it means you have the Q, and that Q you have a pressure, and that you have 2Q actually. Your flow rate should be higher. Then it will not be, there will not be reverse flow. What will happen? The surging is a reverse flow of the air from the delivery side to the suction side. The way when it happened, that's first slide what I had shown, when the pressure increases. Here your pressure is increasing, isn't it? And your delivery also, that the flow also increasing. So with that pressure, then there will be a reverse flow, and then from the inlet it will get released, because there is no valve, and there is the lower pressure side is the inlet side, and then the surging will occur. There will be a reverse flow. So in that left hand side of the surging line, you will be having that condition, the reverse flow. Because your pressure increases, the flow also increases, which is not normal. And that is the reason your turbocharger should operate on the right hand side of the surging line, not on the left hand side of the surging line. Now this orange line description is saying what I said, the blower characteristics at various RPM of the turbocharger. Now the line joining the highest point of the each curve, that is the surge line, and the volume flow of air to the engine is so low that the turbocharger operates on the left side. If turbocharger is operating on the left side, then what will happen? Your demand and supply will not match, that the volume flow rate is very, very less, but the pressure is high. And then at a particular RPM, that surge line, left hand side of the surge line, if you see that at a particular RPM, that is the situation. and the operation of the turbocharger is unstable and surging will take place because your supply is less than the required, but whereas your pressure is high, and then there will be a reverse flow on the opposite direction. On other hand, the volume flow is high enough, the turbocharger is operating in the right hand side of the surge line and operation is stable, because as the pressure in means the pressure it has to match sufficient the volume that the Q has to be there to the engine so that the demand is fulfilled. Whereas the left hand side you have the pressure but your volume is less. That is not normal. Therefore, your mass flow rate will be sufficient, isn't it? But at low pressure, low flow rate, you are getting the high pressure. So that is not normal, and it will not be able to fulfill your demand of air. The supply will be less than the demand. And the So the stable operation you have on the right hand side where the supply will be higher and supply will match with the demand. It will be fixed at that operating condition. So we'll have to keep the margin on the right hand side of the surge line for the operating of your turbocharger, so that even there is a variation of the performance, it will not cross the surge line, so that it will still, there will not be surging. Left hand side of the surge line, it will not shift. So these graphs which indicate the maximum efficiency of the turbocharger when it's operating close to the surging line. But that's the reason it is a compromise. We cannot run the turbocharger at its maximum efficiency because it is very close to your surge line. We need to keep some distance. That's the reason we operate around 70% of the efficiency. So as long means that it has to stable operation to have the efficiency is based on the stable operation. So this is the efficiency curve, this round curve is what you see. So around 75% of the efficiency of the turbocharger, we operate the turbocharger. So the turbocharger is correctly matched with the engine for the optimum efficiency. So the maximum, the supply and demand of the air is matched. And turbocharger performance will depend on the gas, that is the exhaust gas, because the exhaust gas is running the turbine and the turbocharger, that is the blower, is rotating at the same speed, and the speed has to be sufficiently so that it is delivering the correct quantity, as well as the angle at entry of the impeller, that is the air angle at which the impeller, the air is entering, and the diffuser, because it has to be diffuser, increases the NPSH available and it reduces the NPSH required. So correct specific rotor speed you achieve, and the sufficient, the demand and the supply matches. Then other speed, the gas angle does not match to the blade angle, so losses the increases. If it does not match with the blade angle and the gas angle, then what will happen, the speed will not be achieving the correct. So there will be less efficiency of the turbine will be less and the speed will be less. For better efficiency per load, the turbocharger can be designed to overboost the engine. It means what happened actually when at low load, in turbine side, that there is a nozzle ring, the gas velocity it achieved is less because the exhaust temperature is less. What will happen, the attack angle is also changes, and attack angle when it is changes, then what will happen, the turbine efficiency will be reduced and the RPM will reduce. That is the reason what we do actually at the normal operating range, we match the turbocharger and the engine supply and the demand. So turbocharger is designed for higher load, that is the normal operating range, and lower load we don't bother much because it will not run for permanently unless it is the slow speed we run it. Otherwise, normal condition it will not run to that condition. So what will happen, at normal load, that air supply and demand will match, but at lower load it will not match. And lower load, since you are operating for very short time, so it is accepted. Now for better efficiency of the part load, suppose we want to increase the efficiency at part load, then what we do, we design the turbocharger at part load, and then at maximum load what will happen, your turbocharger supply will be higher because you have designed at part load condition the turbocharger matching the supply and demand. At higher load what will happen, the attack angle will be better and the turbocharger RPM will be better, and it will overboost the engine. So you'll have to reduce the RPM. That's why you will provide a bypass valve of the exhaust side. So part of the exhaust does not go through the turbine, it goes to the atmosphere directly. So the RPM of the turbocharger can be controlled, and it is controlled by the scavenge air pressure. As the scavenge air pressure is maintained, then a turbocharger RPM is adjusted accordingly. So that in any load in that condition, what will happen, the supply and demand will match. So wastegate is utilized to achieve this, so that the correct boost at the full load, otherwise it will be over boosted. Then what will happen, turbocharger surging will happen because the complete air will not be consumed, and the pressure on the exhaust in the inlet manifold, that is the scavenge manifold, will increase, and there will be a surging. So there will be a breakdown of the gas flow, and the reversal flow will take place, and scavenge space, a diffuser, and the impeller, there will be a reverse flow, and the surging will occur. And your thrust bearing will failure will happens because of the surging, because bearing is the first thing it gets affected. After that, other parts get affected because the turbocharger have the very bearing will get seized or damaged. Then the impeller will touch the casing will get damaged, impeller will get damaged. Now cause of surging. Now two different things. One is how it happens, that just I had explained with the card, that is how it happened. Now the cause of surging. What can be the reason for having that situation? The fouled compressor turbine. If the compressor turbine is fouled, then what will happen? In that case, the turbine efficiency will reduce. What will happen? At that particular load, the air supply will reduce, and what will happen to the combustion? Combustion will be poor combustion, the exhaust temperature will increase. As the exhaust temperature will increase, what will happen to the RPM of the turbocharger will increase, it will exceed the RPM of the that particular load. Then what will happen? The more air will come, which will not be consumed because the engine will not be able to consume, and then surging will happen. That there will be a reverse flow. Air intake filter is dirty. Then what will happen? Less mass will enter into the scavenge space. In the cylinder, combustion will be poor, exhaust temperature will be high, and the exhaust, the turbine, the turbocharger will run at higher speed, and then it will not match with the load, and then there will be a reverse flow of the air, and there will be a surging. This thing, one of you from the Addis office has asked for that before tea break, coffee break also. He had asked that the water supply, that once I finish this, then I'll explain to that. Before I close, I'll explain to that freshwater generator part. So suppose the power distribution is not equal. That is the reason the thermal power should be equally distributed. Otherwise, what will happen? The power distribution is not equal, then the exhaust temperature will be high because one of the unit is taking more load, thermal load, and that will have the higher exhaust temperature, and then what will happen? The RPM of the turbocharger will not match to that particular load of the engine, and then the supply and the demand will not match, and there will be a reverse flow. Then rapid change in load of RPM. What happened in bad weather? When the propeller, suppose it has come out from the water because of bad weather, governor has reduced the fuel, but what will happen? Governor has reduced, but there is a time delay, because the turbocharger RPM will not reduce the air immediately, because it is running at very high speed. So what will happen? The demand will be less, but the supply will be more. So then there will be a surging, and then what will happen? The next moment it is gone into the water, the propeller will gone into the water. Then what will happen? The load has increased, and then it has increased the fuel, but your air supply will be less, because the previous moment the exhaust temperature was reduced because of the less fuel. Then what will happen? The turbocharger RPM has reduced, and by the time the load has increased. So there is a time delay. It cannot be so fast that turbocharger RPM will match with the load of the engine. Load is changing so fast. So what will happen? The air, the supply and demand will not match, and there will be a reverse flow of the air, and there will be a surging. Fouled hull. Once the hull is fouled, then how it affects the turbocharger? Because your engine load will increase. The engine exhaust temperature will increase, because for the fouling of the hull, it is the resistance, it will give more. So at same RPM, the exhaust temperature will be increased. And then what will happen? The turbine RPM will be increased, and then the RPM of the engine is same, but the turbine RPM will increase, the supply will be high, and then it will not match with the demand and supply, and the the turbocharger surging will take place. Then the high exhaust back pressure. When there is a high exhaust back pressure, what is the problem? Because the exhaust pressure is high, and when the exhaust valve is open, then what will happen? There is a blowdown, and the large quantity of exhaust will come out. But why it will come out? Because of the pressure difference. Cylinder pressure is higher, much higher than the exhaust pressure. Now there is a back pressure. It means the pressure difference will reduce. What will happen when the piston is moving? Suppose it is the air, the exhaust has to come out from the cylinder. So because of the pressure difference, now what will happen? The fuel, the power required to remove those gases from the cylinder will be higher. It has to it will reach to the BDC, and then it will move towards the TDC. It will require the higher power to push out those exhaust through the exhaust, because exhaust pressure is high now. The pressure difference, exhaust back pressure, because of the back pressure, it has to overcome the back pressure. So what will happen? The more fuel it has to consume, and at the same load, more fuel consumed means your exhaust temperature will be increased. It means the RPM is same, but the exhaust temperature will increase. Your RPM of the turbine will be increased, and the demand and supply of air will not match, and there will be a surging. Then pulse turbocharger system. Suppose one section of the nozzle, there are grits in the nozzle. Nozzle means that is the nozzle ring get choked, because we have seen it is a group, three group. Suppose 9 cylinder, there will be 3 grouping. And then what will happen? If that got choked, then what will happen? The cylinder feeding section have higher exhaust temperature, because that is a choke, and the other side is open. So there will be a surging will occur in that case. So that turbocharger supply and the demand, the air supply and the air demand by the engine will not match, and there will be a surging. Now the turbocharger surging, there are common causes, that is exhaust valve not open properly. Then that is the back pressure of the exhaust. Fouled nozzle ring, efficiency of the turbine will reduce. Fouled exhaust inlet grit. So the efficiency of the turbocharger will reduce because the heat energy, complete heat energy will not be going to the turbocharger. Fouled scavenge air cooler, there will be a back pressure generated in the delivery side, and the pressure will keep on increasing, and your exhaust, the scavenge manifold also will get less air, your combustion will be poor, and your RPM will increase of the turbocharger, and the more air will be supplied, and there is a blockage, and then there will be a reverse flow. Pressure on the delivery side will increase, and it will exceed the internal pressure of the turbocharger compressor. Then the choked scavenge port will have the same effect, like scavenge air cooler choke. So the surging, if the surging occurred, first thing what you do, you reduce the speed. Once you reduce the speed, what will happen? Your demand and supply match will reduce. It might not match proper completely, but it will reduce. It means what you are doing, your RPM, you are reducing, exhaust temperature will reduce, the RPM of the turbocharger will reduce. So because of the high flow, that is the reason it is happening. So the supply you are reducing. Once the supply is reduced, your turbocharger will reduce. And first thing what you see, the fouled air side, the filter. If the filter is dirty, you clean the filter, change the filter. And compressor side means the air side fouling you can suspect, and water washing you do, and then air intake filter you clean. And if does not solve the problem, then engine balancing has to be done, so that you know it is the engine problem. The balancing has to be done, indicator card has to be taken, and the balancing of the engine has to be done. So that's why the E and F we should operate not at A. If we operate at A, you can see that it can go to the C. Pressure is same, but your flow is different. A flow rate is high, but C the flow rate is less. So A can shift depending on the operating condition. A can shift to C, and then it can shift to D, and then surging will occur. That is the reason to keep the allowance. What we do, the flow rate we maintain between the E and F, so that it does not reach to the A and then C to D. It is the same thing is written here. So the line of constant speed, airflow increases and the pressure rises and then falls off. So line that peaks, which is the surge line we have seen, and the right hand side of the it is unstable, and left it reduces in flow, gives high the pressure increases, but it reduces the flow. And left of the line is unstable region, so reduction in flow gives a reduction in pressure. And then unstable region, if you work, then there will be a surging. That is the reason we keep it at between the E and F, so that the surging will not, even there is a slight variation of the engine, so there will not be any surging. Surging, it's like braking, barking, or the coughing. It means the, suppose sometimes something goes in your the lungs, towards the lungs, the breathing side, then what happens? We cough to take out. So like that, suddenly that coughing also we call it. For the surging we call it coughing or the barking, because it makes sound like birds. So this is the these are the and if your turbocharger is imbalanced, then also you can have the surging, because that will make also the surging of the, that will make a noise and vibration, that will also have a surging effect. And prevention of the surging, so keep the turbocharger intake filter clean, water washing of the turbine and compressor, proper maintenance of the turbocharger periodically, should blow, because the exhaust back pressure will not be there, should blow of the economizer, indicator card to be taken so that you know that individual units are balanced. So these are the way we prevent of surging. Any question now? Any question? Any doubt up to now? So if no question, then let's move to the next slide. And so let me, yeah, Ephraim, tell me.
Sir, can you explain once more how the compressor is able to keep the air inside the manifold?
Inside the manifold or internal? Which one you want to know? Which manifold? Is it internal pressure you are talking about? I think the...
Yes, sir. Yes, sir.
Yeah, internal, because continuously it is rotating. What will happen? There will be a flow towards the radial direction because it is centrifugal, and but it has got a capacity at maximum how much it can hold internally. Because of that only it is not reverse flow. It does not take place, though that is a delivery pressure is higher than the inlet pressure. Because of that internal pressure it can hold, because continuously it is moving outward direction. Then at one point what will happen, there will not be any movement of the air towards the radial side. It is called stall. It will become stall. And now if your delivery pressure is higher than that, then what will happen? It will push out through the that pressure will be discharged through the inlet. So that is the internal pressure, like what I had drawn before. So this is the compressor and this is the inlet and this is the delivery. So this is P1 and this is P2, and this is internally there is a pressure, and this pressure will be equal to P2. For an example, suppose let us take P3. P2 is equal to P3. Because why, from where this pressure comes? Because of the continuously it is running, so radial direction it will flow will be on the radial direction. So that pressure, it has got a always it is a characteristics of the centrifugal blower. It will have a holding capacity. Because of that holding capacity, the otherwise P1 is equal, P1 is less than P2. Otherwise what will happen? There will be a flow, instead of this direction there will be a flow of opposite direction, but it does not happen because of this P3. And when P2 become more than P3, for that those reason what we have seen, then there will be a breaking. This blockage will be broken. At one point what will happen? The P3 is moving outward direction, isn't it? But at one point it will not move. It will come to a stall, and after that P2 will become more than P3. Then there will be a reverse flow. Is it clear? Have you understood the internal pressure, Ephraim?
Can you repeat once, sir? Sorry, there is a connection problem.
Yeah. So in that case, what will happen? So suppose you see this diagram. This is the blower, and this is the inlet, and this is the outlet. And P1 is the inlet, P2 is the outlet, and P3 is the internal pressure. Now P2 is the equal to P3. Then what will happen? There will not be any flow in the opposite direction. And this is the pressure P3 from where it is coming, because continuously it is radially the flow is going. So there will be an internal pressure, that is P3, and P2 is equal to P3. It will maintain at a particular RPM. As the RPM increases, P2 and P3 also will increase, and it reduces, it will drop. Now what will happen? As long as P3n is equal to P2, then there is no problem. Now what will happen? At one point, suppose your P2, you will keep on increasing. Then what will happen? The P3, this flow of direction will stop first, and then the P2 will keep on increasing, and then there will be this P3 which is holding the reverse flow. It is not allowing reverse flow to happen. That will break, and then the it will come out from the P2 will release through the P2, and P3 will get released through the P1, because beyond that it won't be able to hold at that particular RPM. If it exceed that, then it will not be, delivery is exceeded to that, it will not be able to hold the internal pressure, and internal pressure is coming from the continuous flow in radial direction, and because your turbine is running. But at any particular RPM, there is a maximum pressure it can hold. As per the design, it will not be able to hold more than that. More than that, once it reaches, then first it will stall, because the flow will direction, it will not flow to the delivery side. After that, there will be a reverse flow. It will break towards the inlet side, where is the pressure is less. When the P2 increases further, like P2 should be maximum equal to P3, and then only the flow will be there. Otherwise, there will be the correct direction flow will be there. The moment P2 is become more than the P3, then the reverse flow will start. Have you understood, Ephraim?
Yes,
And
sir, I have understood.
Samuel, you have raised hand. Tell me your question. Okay, Samuel has asked a question that how to cut out the unit during the scavenge fire. So what we do, we lift the roller. So this is the cam, and this is the follower, and this is the roller, and you have the plunger here. What we do, if we can make a gap between the follower and the cam, when cam is on highest position, then we can make a gap. What we do actually, we lift the roller. Roller we can lift. We turn, there is a lever which is projected out of the casing. This is the casing, suppose. This lever is come out here, and it is square head. And then what we do, we turn this with the spanner. We have the spanner. And this spanner has got a slot to this. So you put it onto this, and with the chain block or with the hand, here we can, for fuel pump, we can do it by the hand. We move it, turn it to the 90 degree. Then what will happen? This will lift this roller. Once the roller is lifted, and this roller, once it lifted, then what will happen? This roller, it is, we'll have to push it inside, and then it goes into a slot, and then when you turn it, then it will lift, and it will once it lifts, it will take a new position here. This is the follower, and now there is a gap between the cam and the follower. Even this portion comes here, it will not be, there will be a, still there will be a clearance. So the pump will not operate, the plunger will not move up and down, so there will not be any delivery. And another way we can cut out. Tell me, suppose engine is running and the maker, some maker says that you can do it at low speed. Some maker said, no, you'll have to stop the engine and then you can lift the roller. In that case, suppose you cannot stop the engine, but you need to cut off the unit. How will you cut off? The fuel rack, put it to the, the fuel rack has a linkage. That linkage you remove, and then you push the fuel rack to the zero position. Zero position is the no delivery position. So the fuel will be cut off to that unit. So best way to do this, because there is no, the plunger is not reciprocating in that case, but there the plunger will keep on reciprocating, but there will not be any delivery. Clear, understood, Samuel? Now let me explain that one of you from Addis office wants to know the freshwater generator. Maybe probably you missed that portion, because in the diagram it is not there, but it in the lecture I had mentioned that. But before that, any question on this? Yeah, any question on this?
My question is on COTs.
Tell me your question.
I didn't have a question on today's topic.
Okay, in the freshwater generator, you had some question, isn't it? That's from Addis office only, I think.
Yes. Yes.
Yeah, let me explain that. Just tell me which diagram you are talking about. Are you talking about this diagram? Addis office, are you talking about this diagram?
Which diagram, sir? It's not showing on the screen.
On screen, it's not showing?
Yes, Chief.
Now is it showing?
But the alpha level one, not this one.
Yeah, so this one, correct? So what is your question? The seawater inlet.
Yes,
yeah, tell me the question.
Is where is the seawater supply line for the
This one you are talking about, from where it is coming?
Yes, sir. I think we need a seawater supply pump.
So this is the ejector pump, which is taking suction from the seawater main. So this is ejector pump. Is it clear?
Yes, Chief. Now it's full.
You can add it. This ejector pump, you can add it.
Okay.
So now we have actually 10 minutes still. So anybody, any question till now? So we can start the low load operation. So let us see what is the, when you use the low load operation, what is the problem? There are some problem for the low load operation. Now tell me what can be the problem. Low load operation of the engine we are using because what is the reason for using that? That is for the economic reason. So we have the commercial reason we are doing so, but for the engine it is not good for the engine. We know the performance of the engine as high load is better because your design of the engine is for the higher load. That is the problem. Now tell me, what can be, how many of you have seen the low load operation? I think you might have seen, isn't it? Have you faced any problem with the engine because of the low load operation? Just think and answer me. What can have adverse effect on the engine for low load operation? And when you write something, you must know the reason. When you say something, definitely I'll ask that what is the reason. So just think, low load operation, what is the adverse effect? What are the adverse effect on the engine? Yes, like Abraham says that incomplete combustion. That's correct, absolutely correct. Fouling of exhaust valve, absolutely correct. Fouling of turbocharger, that's correct. EGB heating tube, because EGB will be dirty, and it is also correct, and leads to uptake fire, that is also correct. And boiler has to run, that is also correct. But for the engine, what are the adverse effect? Anything else? Khalid, tell me.
Auxiliary blower cutoff.
Auxiliary blower will cut off or cut in?
Cut in, I mean.
Yeah, auxiliary blower is another problem, because what will happen? Auxiliary blower will frequently cut in and cut off, because the depending on the sea condition, it's not necessary it will auxiliary blower will run continuously. Suppose the load increases, it will cut off. Again, load reduces, it will like that is the thermal load, because your turbocharger RPM will be based on the thermal load, that is the exhaust temperature. And what will happen? It will frequently cut in, cut off. Anything else? That is correct. What Khalid said. Till now, whatever you have answered, it's correct. And what else?
Also, cylinder lubrication will not be.
Yes, cylinder lubrication will be affected. Why? Because the speed of the piston will reduce at reduced RPM. That is another problem. Then, next. So what else? Suppose, yeah, Khalid, tell me.
During low operation, there might be some unburned deposit, so that will bring a fire.
Yes, unburned fuel, because there will be incomplete combustion. Definitely. So, anything else? Liner wear and the corrosion. Yeah, there will be liner wear because of the incomplete combustion. There will be deposit on the liner surface and the your piston ring. It will get worn out faster. As well as that the lube oil, cylinder lube oil will be affected. Now tell me, the you have the scavenge valve, isn't it, in the scavenge manifold? Will there be any effect on that? Those reed valves, low inertia reed valves. Okay, before that, you tell me your the auxiliary blower will cut in, cut off frequently. What will be the effect on the auxiliary blower? Yeah, Khalid, tell me.
On the engine, the load fluctuation will be there, so that this load fluctuation may lead to the compressor, I mean the blower turbocharger bearing may be damaged.
What about the auxiliary blower? What will happen to the auxiliary blower?
Cut in, cut off, then there might be disturbance for the operation. That will lead to the damage component for the component.
And what will happen to the reed valves? Reed valves are those low inertia valve which is there in the scavenge manifold. For the auxiliary blower also will be having the non-return valve, suction and delivery, isn't it? What will happen to those? So that valve also will break, isn't it? Your frequent start and yeah, Khalid, tell me. Because yeah, Khalid, tell me.
Same.
Yeah, because your auxiliary blower frequent start or stop, and that also will close and open frequently, and those are very low inertia valve. That plate will damage. So what we do this portion because this is a very important part of the operation of the ships nowadays, and there are many points actually. That's why I did not stop it. It would not have completed. So next class I'll start from here, and tomorrow one of the class I'll convert into electricity class. So in the morning. Will today any other question you have today? So if no question, then what do? We close at that point today, and then 8:15 tomorrow we'll start again.